We're all good, Kieran.
Fantastic. Thanks so very much indeed. And so good morning, everybody, and welcome to this tree maps and tree mapping workshop. My name is Kieran Doig. I head up the Urban Forest Research Group at Forest Research. And it's my absolute pleasure to be able to open this session with you all today. Having chatted with Sue James at TDAG about the need to get people together to talk about this agenda and what is going on with our tree maps and new technology arising, it was just so great to have the opportunity to work with Sue at TDAG and Emma at the University of Birmingham to make this workshop happen. So I'm just here to thank you all for attending and to introduce you to our chair for the day, Holger Kessler from the Geospatial Commission. And I'm going to hand over to Holger now, who's going to take us through the morning. Thanks again so much. And I really look forward to an exciting session with you all. Thank you to our speakers and thank you for all the questions that I know are pending. Okay, over to you, Holger. Thanks very much.
Yeah, great. And thanks for having me, for inviting me to chair. As I said before here and on social media, it's a really exciting workshop. A shame we can't be together in person. It's a great topic and a lot of interest. As we can see, the room is still filling up. So I have just got a few housekeeping items. The meeting is being recorded for people who are just joining, and it will be made available via the TDAG website. Questions, please, in the chat. If there is time after the presentations, we might take some questions out of the chat, and we might even have the ability to put your hand up if there is space. And I'm feeling the bandwidth going slightly laggy here. So if after you've sort of seen all of us, if you can have your cameras off, unless you are talking or presenting, because I think we're sort of hitting the limits of our broadband infrastructure, certainly here in rural Nottinghamshire. So we also will have a graphical recording being done throughout the session, so we should have some nice artwork at the end of it. So just a quick few words from me. My name is Holger Kessler. I am a geographer, work at the Geospatial Commission at the moment on the Underground Asset Register, which is looking to digitize our buried infrastructure. But I am passionate about trees, and I'm just going to share my screen. Can someone give me a feedback if that's coming up? Because I can't actually see.
Yes, we can see it.
There. So it's this. Yeah, so it's this diagram that Sue and I talked about in the last few weeks, which sort of really nicely represents the interaction of the trees with the surface and the subsurface, and the many functions they fulfill in the urban, but also obviously in the rural environment, and the conflicts and pressures that arise and interact. And it's such a great representation of all the interactions. From sort of my fields, which is the sort of geology, soil, archaeological side, and now the buried infrastructure, and all the stuff that goes on above ground. The other thing I quickly wanted to bring up is a document put together by a whole range of organizations that you can see here a year ago, which is a vision for a built environment that actually has, as you can see in this beautiful diagram here, a combination of the built and the natural environment. So it's really pleasing to see so many different people and organizations represented today coming together, like in this diagram, to look what are the outcomes for people and nature that require the working between the engineered and the physical environment and the natural systems, such as our rivers, the soil, and the plants. And I really am, as a geographer and a geologist, really pleased to see that we're beginning to more and more think collaboratively and together how we provide better outcomes for people and the planet. So that's my final word, wise words here, is that I would like to say that this is this session is not about competition. We will have lots of presentations of different types of maps and mapping, different scales, different resolutions. Competition is good to sometimes find solutions for a specific problem, but what we need here today, and what this should be the start of, is we need collaboration in order to solve the issues of urban trees in particular, but also many others. Because as a diagram I showed, you have so many different interactions from the transport, from the social science, people moving around, and the hard engineering. So collaboration I would like to have as the theme throughout the day. And this is not a sort of sales and competition who makes the best tree map, but it's about finding each other and working together to improve things. So that is all from me. I really look forward to it. And I'm going to introduce the first speaker. Hopefully, Ralph is ready. Ralph from Blue Sky to tell us hello about the National Tree Map. The floor is yours.
Thank you very much, Holger. Can everyone hear me?
Yes.
Excellent.
Yeah.
Right, I'm just going to share my screen. Okay, is everyone able to see my screen?
Yes, thank you.
Yes.
Fantastic. Okay, well, thank you very much for the introduction, Holger. My name is Ralph Coleman. I'm the Sales Director at Blue Sky International Limited. So firstly, I just want to say a big thank you for the invite to talk. It's a great opportunity for us as an organisation to showcase what we've been doing with our tree mapping that's been around for a number of years now. Hopefully some of you will have heard of our National Tree Map, and I imagine some of you have perhaps been users or are users of the tree map. So for the next 15 minutes or so, I'm going to tell you a little bit more about the National Tree Map, hopefully what the future holds for the tree map, and how we can collaborate and work with the other organisations as part of this, but also more broadly to further the whole tree mapping agenda for the UK and elsewhere. So very quickly, and I'm not going to dwell on this, just a little bit about Blue Sky. So we're a leading aerial survey company and geospatial data company based in the UK. We've got offices in Ireland, in the US, in India. We're privately owned, established in 2003. We work with a really diverse range of market sectors across the UK and Ireland, and then some in the US, as I say. We've got a really proud history serving the public sector in the UK and Ireland. So we are the lead contractor for the APGB contract, providing aerial photography and terrain data sets to all public sector organisations throughout the UK. We like to think we can create and provide accurate, high-quality data, off-the-shelf data and bespoke projects, again, to a broad range of customers. And then the National Tree Map being a really important one of those products. Okay, so the National Tree Map itself, I think as a geospatial data company, we have a broad range of products that we developed over the past few years, but I think one of the most successful certainly has been our National Tree Map. And we're particularly focused at the moment on products that are applicable to the whole environment agenda. Although the tree map was actually conceived for the challenges in the insurance market. So we were looking at mapping trees for subsidence risk around buildings, and that's how we got into creating the National Tree Map. Although we soon realised that the tree map was actually applicable to a whole range of different markets, and it became quite popular with a whole range of different customers. Just going to try and move on to the next slide. It will move on. Oh, sorry, there we go. So what is the National Tree Map? The data set itself isn't necessarily that complex. It's a fairly simple set of vector layers that contain a few key attributes, as you can see on the screen here. I think that the complexity comes more with how we generate and create the tree map from our core products, the aerial photography and the terrain data sets that we use to generate the tree map itself. But I think the other component to this is the ability to keep the national tree map updated, and that mirrors our national update programme of aerial photography and terrain data sets, which is on a 3-year rolling programme. And this enables us and users to track change in tree canopy coverage and provide a baseline. And that's obviously something really critical to understanding the broader management of the trees and the relationship with environmental sustainability and other applications. Currently, the National Tree Map has 2 full epochs for England and Wales, so 2 full layers of all tree canopy across the whole of England and Wales, one for the Republic of Ireland, which we've recently completed, and we're also well underway with completing our Scottish version of the National Tree Map as well, and the aim is to have that finished for the end of 2022. And the reason we haven't managed to have Scotland up and running yet is we've had some inherent challenges with base data sets that we've now overcome. So fingers crossed, Scotland will be joining England, Wales and Ireland by the end of the year, which we're really, really excited about. And I think one of the key things with the National Tree Map is that although a lot of the tree map is generated using semi-automated and automated techniques with quite complex algorithms, actually we still do have quite an onerous QA process that goes on afterwards. So there is manual intervention, and we do, it's not a perfect science, so we do have to still go through that QA process. So there's quite a lot of hard work that goes into cleaning up the tree map, getting rid of things like false positives where we've identified features that perhaps aren't trees. So just looking here very quickly at the key attributes. So the attributes of the tree map are the spatial location of all the trees, the height of trees, which we derived from our digital terrain models and surface models, but also the size of the tree canopy. And it comes in sort of 3 different flavors. The first flavor is a gridded identification of the tree canopy, as you can see on number 1 here on the right hand side of this slide. The second is what we like to call an idealized tree canopy. So people think that trees are these lovely circular entities, but so we generalize and idealize the tree canopies into regular circles. And then the third is just a point, which is actually the highest point of the tree as a point data set as well. So there's just 3 separate vector layers there that contain various attributes. So as I alluded to, the creation of this tree map wasn't without challenge. And I think there were various elements that we've had to modify over the years. So with it being it's almost 12 years old now since we first launched the tree map, I think one of the first things we identified was when we started marketing the tree map, we were very much talking about it as a map that identified all trees throughout the country. And I think we were perhaps a touch naive in that regard. It clearly doesn't identify every single tree because we have trees underneath trees that we can't pick up. Where you've got large groups of homogeneous trees of all the same species, it does occasionally struggle to pick out individual trees in those areas. So it quickly became apparent that actually the tree map was better communicated as a canopy map. And that's not to say that we don't identify individual trees well, particularly in urban areas where they stand out from man-made concrete, tarmac, whatever. And certainly trees in hedgerows and things like that stand out very well. But I think that is just an appreciation that that we don't pick out every single tree, although it does do, we believe, a good job of identifying tree canopy and measuring tree canopy. The other challenge was keeping the data current. So as I say, we want to try and keep this data in line with our 3-year update program. That's not always quite been the case through the last 10 or 11 years or so. We struggled to keep up with that update program for a little while, but we are now fully back up to date again, and moving forward, the National Tree Map should be updated on that same 3-year rolling program for the whole of the UK and Republic of Ireland. One of the other challenges was methodologies. So we've continually sought to improve the way we identify trees and create the National Tree Map. That has led to a few issues with using the data. So something that was pointed out to us was that actually if we altered the methodology of actually creating the tree canopy, where people could have seen an increase or a decrease in tree canopy, that may not have necessarily been down to the tree canopy increasing in real world terms. It might have been that we were just identifying the tree canopy better using the map. However, more recently, we've standardized that process, so that shouldn't be so much of an issue moving forward. A few of the other output challenges we've had to overcome. It's a large data set, so we've had to find ways of compressing the data, delivering the data to customers in methods that are usable, and we've now also set up the tree map on our web services so it can be streamed directly into to applicate the end users' applications. So what I want to do now is quickly move on to the use of the tree map, and I'm conscious that I haven't got a great deal of time, so I'm going to fly through some of this a little bit. As I alluded to previously, the initial use of the tree map was very much about trees as a risk. So, and I would still say that probably 50% of the use of the National Tree Map is about risk. So this is about maintaining trees as a risk, knowing the location and size of the trees, obviously enables practitioners to prioritise cutting of trees or designate particular areas as higher risk than others. And this is obviously going to be attached to insurance. Unfortunately, we are living in an increasingly more litigious society, so trees do pose a risk to both the public, to property, and other items. So that is where we've seen a lot of the usership. However, more recently, we've seen a far more diverse range of applications. Excuse me, I'm just going to just wipe my nose. I've got a bit of a summer cold coming on, I think. We've seen a whole range of diverse applications for the tree map, things like some of the more interesting ones, leaf crews at local authorities for their leaf litter drifts, where they've been prioritising areas to send out their leaf littering crews, utilities trying to predict where their pipe bursts might be from the tree roots, and also modelling air quality in street canyons. So lots and lots of different applications have arisen since since the inception of the tree map. And a number of those applications, unsurprisingly, have centred around canopy coverage. So measuring canopy coverage across various areas, whether that's nationally, locally, regionally. And because of that, we've had quite a lot of interest from national press. So we've seen quite a lot of the national newspapers run articles about the National Tree Map, relate that to things like deprivation, social deprivation. Is there a link between social deprivation and the amount of trees in particular areas, and that sort of thing? So lots of interesting work going on around that, and being able to measure and quantify the tree canopy across various different areas. And we've collaborated with other organisations on that, both in the public and private sector, and we've allowed the tree map to be used quite broadly throughout UK academia as well, at reduced prices, but also sometimes completely free to measure that tree canopy. And I'm probably preaching to the converted here, so I'm going to moving on a little bit now to how much trees have moved up the agenda more generally. So we've seen that trees have fought their way up the agenda, and they're finally getting sort of the recognition that they should have had for a long time now. And I think things like the Queen's Green Canopy project more recently, even Sleepy Joe Biden getting involved in talking about trees in the US, which a few years ago probably would have been unthinkable. So trees really moving their way up the agenda, and people standing up and taking notice about how important trees are going to be to the whole carbon reduction agenda and moving towards net zero and these kind of things. So fantastic news for trees and everyone interested in protecting trees themselves. So and this really moves on to this supporting this fight against climate change. So more recently, we've certainly seen the NTM dataset take on a whole new and very important role within this agenda. I think, again, moving towards net zero, becoming so important and becoming so high profile, knowing about the landscape and what it comprises in terms of trees and other vegetation and other features is really critical. And I think the National Tree Map is hopefully detailed and current enough to provide this really clear picture of where trees are, and sometimes more importantly, actually where trees aren't, interestingly. So I'm conscious I've not got that much more time, but I just want to really race through a few customer case studies, because I think it's really important that we show some of the uses of the tree map. So as I alluded to, we've been working with lots of other organisations with the National Tree Map as well. And one of those is an organisation called Treeconomics. And I'm sure lots of you will be familiar with Treeconomics. They're a social enterprise who have been working with a range of customers to help them understand their trees and better manage those trees as a dynamic asset. And I think their mantra is sustainable treescapes for everyone. So that fits quite well with the agenda here. And I think one of the key customer bases for Treeconomics are local authorities, and this was a project they were doing with London Borough of Islington. So this is a really key case of knowing where trees aren't rather than they are. So they worked with the London Borough of Islington to prioritise and weight the environmental and socioeconomic factors of most concern to create what they called a multi-criteria analysis of tree planting. So what they established was a map, an evidence-based map of canopy cover to inform their tree planting, where their tree planting should take place. So I think this is a really good example of a local authority using a tree mapping database to inform where they should be planting trees for the future. Similar application here for Waterford in Ireland. So Waterford are a long-term customer of Blue Sky for aerial photography and other products. They adopted the National Tree Map, and this was more specifically connected with their drive towards net zero. A similar application, looking at where their tree canopy existed, where their tree planting should take place, managing that whole process, using the National Tree Map as a basis for that process. White Rose Forest, so they're a community forest up in the north and West Yorkshire. This was a slightly larger scale project, around 20,000 square kilometres, I believe. And one of the challenges they previously had was mapping their treescapes across that area, because it was a quite large area. And what they realised is, using free data sets that are available on the market, they were vastly underestimating the amount of tree canopy in some of their areas. So, for example, in the city of York, when they licensed the National Tree Map, they realised they were underestimating the tree canopy by something like 60%. So quite a big difference there from using free data to the National Tree Map. And then very quickly, something. I wasn't aware of this thing called natural capital until a few years ago, but it's apparently a thing now, natural capital, and I'm learning quite a lot about it just recently. So, but I'm a bit of a beginner around it. So, I think the best definition of natural capital I've found was it's let me find it. I'm just going to read it out here. It's a way of classifying natural things such as water, clean air, or importantly in this context, forestry trees as assets. There is therefore a risk to financial institutions when these assets are threatened, and therefore it's important that they are measured as accurately as possible so these risks can be managed and mitigated. So this has opened up a whole new area of business for organisations like Natural Capital Research, who are a company that we're currently working with. They've been using the National Tree Map to benchmark tree canopy and create their natural capital database for the whole of the country, amongst other data sets as well. But they've used the tree map heavily to create that benchmark of natural capital across the whole country. And they're working with a whole range of different land owners and stakeholders to measure that natural capital as an asset. And this is just a bit of detail about how they used it here, using the tree canopy data set to identify that natural capital. So again, conscious of time, so I'm just going to conclude here. I think for us, the National Tree Map has been a huge success since its launch about 10 years ago. But for us at Blue Sky, it still sort of feels like the start. I think we feel that there's so much more potential for the National Tree Map, and I think we've got a real desire to work with our customers and partners to improve the tree map. And I think that also the technology and the data available is improving so much that I think it's now a realistic ambition for us to start aspiring to to add new attributes to the national tree map. So I think most of my presentations of the tree map over the past 10 years have ended with people saying, what about species? And we'd love to have species as part of the national tree map, obviously. But that's it's a challenge at any scale. But in smaller areas, we've been able to do that, working with partners. Nationally, doing that at scale is still very challenging, although we do genuinely believe having a species is a realistic ambition for us, which would be absolutely incredible. So you can see here.
Hi,
Sorry,
Rob.
someone.
Sorry.
Hi.
Yep.
Hi, Holger.
Sorry. I need to sort of try and get you to a close, if that's possible. Great.
Sure. This is the last slide. Thanks, Holger. So just in conclusion, I think we all know that trees probably always will be and have been big business. The way they're perceived, we believe, is changing, though. They used to be viewed as a bit of a commodity or an obstruction, but they're now considered an opportunity. So I think we think the National Tree Map's a huge part of the puzzle for a growing number of organisations, and it really has the potential to evolve and become an even greater force for good in an increasingly diverse range of markets. And that's me done, Holger. Sorry, I've taken a bit longer. That's okay.
No, you've done well, because I took 2 minutes off you at the beginning.
That's fine.
You have some really good questions in the chat. We would like you to answer some of those as you now have time to, whilst we listen to Kitty from the Ordnance Survey. As Sue said in the chat, we will look at all the questions. One of them you've answered, that species is what is for the future. But thanks a lot for the first talk there. And yeah, Kitty, from Strategic Development Manager from the Ordnance Survey, tell us about what the OS is doing in this space.
So, morning everybody, welcome, and thank you very much for this opportunity. Do you want to confirm that you can see my screen okay?
We can, Kitty, thank you.
Wonderful. Okay, so my name is Kitty Rose and I work for the Ordnance Survey. I've been here about 3.5 years, and I spent the first 3 years of my life here working with our government customers in the environment sector. So looking after the likes of DEFRA, an Environment Agency, Rural Payments Agency, and a number of other customers in that space, particularly local authorities. There's also a lot of speakers today that we've supported through other initiatives. So what I'm really clear about is that we are here to collaborate and support. We probably haven't got the data that you need to answer your problems, but we're definitely here to help in that way. So Ordnance Survey, we are a government-owned commercial entity. We are owned by BEIS, Business, Energy and Industrial Strategy Department. And we have 3 main parts of our business. So that's to do with the consumer part, where you've got OS Maps, the app, our paper maps. We have our commercial part, which looks at our partner channels. There's over 500 of those selling our data across the UK. And we also have an international branch as well. The main part, I think, that we focused on, and where I've come from, is the part that supports the PSGA. So this is the Public Sector Geospatial Agreement, and this supports over 5,000 government agencies, arm's length bodies, and any other member of local government as well. So what is the PSJ? So this is a 10-year agreement that we've got, and it provides richer data, new ways to access our data, and freedoms to share that in better ways than we've done in the past. So some of those things that we've got going on at the moment is that we've got a future 65 data asks that are going to be coming out in the next 2 years, that based on our current version of products that we've got. New ways to access our data. We've got a data exploration license. We've got contractors licenses you may come across, but people who know OS data can find that sometimes our licensing and our pricing can make it a bit of an inhibitor to using it in your everyday work. Because we are centrally funded by government, our core purpose here is to support public sector entities to do their public tasks. And we have managed to support a number of tree initiatives under this. And a lot of them include the DEFRA Elm trials. So that's the environmental land management schemes that have started in the last 3 years, or looking about how we can improve nature. We've also supported some local nature recovery strategies and the planning of future woodlands from councils and local nature trusts that have been funded via government agencies. Other things that we also get involved in are also to do with the Environment Agency and flooding. I won't go on to anything else because I know we've got Alistair on the call who's going to talk about his LiDAR data later on. And future things we've done include the peatland monitoring from Earth observation data. So the easiest thing that we've got for our data hub, which was released last year, stopped using 3 different ways of getting our data, and now it's much more simpler to get on. So you'll find that you can go online and anybody can access the data hub, and through this we have a number of options. There's 3 different plans: the free one, the premium one, and the public sector plan. And as part of that, you can either download the data sets, or you could also have the APIs, particularly that might be useful for what you want to do in that way. What we have found through this is that means that our data can be used as that baseline mapping when we've been doing work with natural capital planning for the assets and flows of the land, and understanding what we need to do for the vegetation. And we have a number of products in that place. So we've got the heighted vegetation, the digital terrain model, but that's a premium product, which means that sometimes that barrier of licensing and pricing means that it can't be used every day. Other things are good. We've got OS Open Green Space so that everybody could use that free at the point of use, but we know that that doesn't necessarily provide the detail that you need for your tree mapping in that respect. So the thing that I guess I want to promote to everybody on the call is the data exploration license, because not everybody's aware of it. And that means that you can use OS data for up to 12 months for all of your internal purposes. So you can help that with your baseline mapping and combining it with things like the National Tree Map or data sets from data.gov to really understand that interoperability of data that's needed when we look at tree mapping going forwards. We've got over 50 products that work for OS. Not all of them are related to trees and the vegetation area, but there are improvements. And I think looking at it from an address-based point of view, and we've done a number of use cases where we've looked at actually the built environment and where tree planning should be done in that respect. So what you'll all probably be aware of, I think, is that we use our data as master map. And this is probably the best one that we've got that shows that intricate detail that you need for the tree mapping. So a number of our customers have used this to understand where should future tree areas be improved, or also if they know that tree deforestation occurs, what are the ongoing effects in that respect of improving the area that goes from there. So we've got green space, forestry and vegetation comes about this, and it's all about those physical features and also the intangible features such as boundaries and tide lines, which can be really important about planning on sort of a local and a national scale about how we can improve our natural environment. So I'd like to introduce the National Geographic database, and I think this is a key part of how OS is changing. So we've got land cover and land use as one of our 9 themes under the National Geographic database. So this means that you won't have to take the whole of master map and then decide what parts you'd like to do, and from that you can then do a bit of a select and build, as we call it, and just pick out certain things. So you can have heighted vegetation to a certain parameter, you can have water networks and culverts to a certain size or depth or width that will then help you with your analysis in that respect. And during the next 2 years, we've got over 70 enhancements to this coming. And particularly, I think that land cover and land use are really clear as needing improvements to do with tree mapping. So we've got the improved rural land cover classifications, and these are going to be mapped to the UNIS codes. So everyone will be aware of the European Nature Identification Service. And also we map to the JNCC broad habitat specification as well. So including those data sets into our data and those schemas should help mean that our data provides a bit more better baselining for your future analysis going from on there. Other parts I think I'd like to highlight include the boundary sets. So we're improving those administrative boundaries and aligning them to those topographic features. So you aren't going to end up with a line of a boundary halfway through a river or halfway through a forest, which doesn't really help with your analysis and planning going forwards. A number of our current projects that I'd like to highlight, I think, of how you can use our data in that way, is the Peatland Health Index. So we presented this at COP26. And it shows you using satellite imagery alongside our other aerial imagery and our surveyors information to provide that health index for peatland. What I'm really clear is that this is just a starting point, and this has been a test case for us, and we are looking at how we could do this for things like tree canopy and carbon sequestration as well in that manner. In the DEFRA Elm trials that we've supported, we did 54 trials supporting in the first year, and then DEFRA required us to reduce the scope of support in that respect and only looking at land use and land planning. And so then we've partnered with FWAG Southwest, so the Farming and Wildlife Advisory Group, and they currently have a phase 3 trial under the Environmental Land Management System, which are looking at baseline mapping with natural capital, but also understanding about where local trees should be planted to help with the benefits for schools and children, as well as enhancing the environment in that way. There's lots I could go into on all of those, but I think the best way is probably just to send you the links to those websites, because they will have case studies and videos on them so that they can see exactly what we've done and when. And also to understand, maybe you've come across something that you'd like to do that we could work with you in the future as well. The OS data, as I've briefly kind of run through, the data hub is the quickest and easiest way to get hold of our data. And this just is a broad reach of all of the sort of products that we've used in this events. And I will send around all the links of how to get in contact with us and how you can maybe use our products to go in that respect. Things that I also wanted to bring up about, I think, as part of a discussion point of this, is that we have a lot of partners in this space, and you will have come across ones like the Land app with Tim Hopkin, where they're bringing together lots of different data sets and making it much more accessible to communities and using that way. Then they're ones that you can investigate and we can join in, but they're one of only 500 partners that we've got within OS to look for that. So that's my whistle-stop tour of on a survey. I can see some things in the chat, so perhaps I'll address some of those now, if that's okay.
Superb stuff, Kitty. So you've got a couple of detailed questions, one to do with the CEH land cover map, and also a bit further up, you've got quite a specific question about the good old projection system issue between network and SnakeNet.
Great. So the land cover and land use relates to CEH. So as a broad discussion of those, CEH has 27 different land cover classifications and we have 24. The biggest difference between ours and theirs is to do with heather, mountain and moorland. As part of one of our ongoing improvements through the PSGA, which is expected in sort of about March 24, I think, or Q2 in 24, is the improvement of our land use and land cover maps. And we have worked with CEH on that. CEH are not part of the public sector geospatial agreement because they're a research body, so we have to collaborate with them in that respect. But yeah, they have helped us with our enhancements. Another part of that land cover and land use improvement is going to be the field boundaries data set that's going to be coming out later in sort of 24, 25. And this is based on the Rural Payments Agency's hedges contract that we have at the moment, which is what they use to help produce their funding for the farmers that they support through Basic Payment Scheme and the new ELM system in that respect.
Yeah, really, really good, Kitty, and this is probably one for our notebook to see why CEH and the UKRI family of organisations are not part of the PSGA, and this is probably something we could raise at the Geospatial Commission.
Okay. Regarding the question about the NR snake grid and things, I would have to be technical because that's not my remit. But yeah, if you want to send me a message direct with your email, I can get our technical team to explain it fully to you in that respect.
Very good. What is the best land cover data set for use in urban areas? Well,
well, I guess if we're going for the UK, in that respect, I would probably say you'd have to use a combination. And I think that's the biggest problem that we've had. We've done some trials, particularly in urban areas, basing on some of the unitary authorities. So looking at West Midlands is a good part, the combined authorities for Birmingham, Manchester and London. And there isn't a land cover data set that works best in one of those particular areas. And I think that's where we need to go further forwards, is understanding that difference. And that peri-urban area is also the best part. So you'll see some free tools out there, I think, that do really good land cover. There's a new one at the moment called Zulu Forest, done by Alex Robinson, that's really good about understanding your natural capital as well as your land cover. But it really depends on the resolution of the data that you need to have in that respect. So with regard to the land ownership data, there is part of it, but land ownership is controlled if you're in the urban environment by Land Registry, and if you're in the rural environment, that will be part of the Rural Land Register with RPA and DEFRA. That is something that I think as a whole in government we want to improve upon, but it is to do with GDPR, and I think also the commercial information that those data sets hold at the moment is really not able to be included in all of our things. We are working with Land Registry because we have contracts with them that run over sort of 5, 10, 15 years. And that is something that's important that they want to share. But you also have to include the valuation office who don't want to share anything at all. So although you have Land Registry hold the data set, that can be really hard to do. There was a study we did last year about land ownership, and about 28% of England is something that is a bit of a query about how we could find out land ownership. And it's a lot of what our surveyors spend their time doing at the moment. We are given cases by Land Registry or Valuation Office to track down land ownership and boundaries in that respect. So there are some case studies on our website that I can point you in the direction of.
Yeah, thanks for that. And I'm just going to put the hand up for the Geospatial Commission, who is working behind the scenes with Valuation Office Agency and Land Registry to unlock some of the difficulties that Kitty just mentioned. So if anybody in the meeting wants to message me directly or write into the Geospatial Commission with a particular use case, particularly if you're in the public sector, local authority, and you have difficulties, we're always interested to hear specific use cases where we could make a difference without promising, but we need to find out the list of uses. Cool. Yes, so that means have you looked up a little bit on the chat? I think that is all there. So we have actually got a nice little bit of breathing space. We don't have to rush too much, but I think what's coming out for me already in the chat in general for the two speakers, there are lots of questions about some of the technical detail and some of the links you've mentioned. We're obviously going to share the recording and the presentations, but I think an outcome and an output from today will also be, maybe just a list of some of the technical details behind the presentations, like you mentioned the data portal and the various and the PSGA, and there's a lot there, and there's quite a lot of people in the audience who probably have never heard any of these acronyms, so bear with us. And yes, so Russell, are you? Yes, I can see you are ready.
Yes,
thank you, Kitty. Russell from Tree Plotter Canopy will give us 20 minutes on what you're doing in the space.
Brilliant, thank you very much. So yeah, thank you for the opportunity to speak today. I'm going to kind of follow on from the previous two speakers, and in terms of collaboration, I think, as we're partners with both Blue Sky and with OS, so I think collaboration is the key, and we're going to continue with that. Today we're going to talk about what we're doing in the space in terms of urban tree canopy assessments and how that can help people do better community engagement. Tree Plotter as a suite is a suite of a number of different software packages. We've got numerous councils, private practices using Tree Plotter inventory to manage their tree stock. We're just launching a new product called Tree Plotter Jobs, which is to help tree surgeons better manage their day-to-day work. We're going to talk about Tree Canopy in a bit, which is our AI-driven analysis and visualization for urban forest planning. And then we're also working with other organizations to manage their parks and assets. And I think that's what we're seeing at the moment is more and more people are wanting to move digital, and we're keen to work together to help them do that. We've got over 400 clients across 20 different countries. I said across the UK, we've got a multitude of different companies and clients. We're currently doing some interesting work with Network Rail, looking at biodiversity net gain, which is a new area for us, and we're starting to map that with them and work with them, as well as looking at things like, how do people, map nesting birds and where birds are nesting when they go out and do their tree works. As a business, we've worked quite hard in terms of we're trying to open up the space, I think. So we're cloud-based and we license different organizations, and that allows them to have unlimited users. And we think this is really important in terms of engaging with the public, because it allows you to set different roles. It allows people to have different access to different bits of data. And we think that the more and more people that have access to data, the better things are going to be. And community-based working is a lot of what we're about. So, what is a tree canopy assessment for those of you that don't know, and some of you will do. So basically what we're looking to do is we're looking to start to measure a tree canopy across a community And we can use a mixture of different things to do that. We can look at satellite data, we can look at aerial imagery, we can look at LiDAR imagery. Blue sky data that Ralph mentioned earlier is a part of the case study I'm going to show you in a minute. So we've used that data. And what we're looking at is we're looking at the total land area covered by existing tree canopy, both on public and private lands, but also, and I think this is kind of a key thing, is about identifying available planting space. We're seeing a big push for tree strategies and people starting to come out with, we're wanting to plant millions of trees. But I think unless you've done a tree canopy assessment, it can be very difficult to know whether or not you can actually reach those. So, are we setting realistic targets? Once you've kind of done a canopy data assessment, it's interesting. You can start to look at trends. We can start to look at, Blue Sky mentioned earlier that, they've run 2 sets of data now for England. So we can start to look and say, well, what have the changes been over that 3-year period? And that can help you in terms of when you do set realistic canopy goals, then evaluate, moving forwards, are we reaching those? Are we moving forwards? You can start to prioritize your plantings and you can start to set programs and set budgets to those programs. So what are we doing? So, as I said, there's a big push specifically in England about the need for tree strategies. And I think it's key that, you understand, and as part of those strategies, set some decent targets, and the iTree canopy can do that. And I guess there's been a lot of push in terms of iTree ecos, and a lot of projects have been done across the UK, but they can take a long time and they produce different data sets. So iTree canopy is looking to produce different data, but the project can take weeks rather than months. So actually, in terms of if you're looking to embark on a strategy, an iTree canopy project can be done very quickly. We're also just about to start some work with the Woodland Trust, looking at a tree equity project, because they're really interested in looking at areas of deprivation. And that's something that we've built into our canopy tool. I'm going to talk about a case study, and a big thank you to the Birmingham Tree people and Simon Needle from Birmingham Council, who we've worked with there. We've initially worked with Birmingham. It's the largest conurbation outside of London. It's got, like most cities, it's got issues with air pollution. It's got issues with, demand for housing. There are issues of flooding, and our canopy tool allows them to start to look at all of these things and set priorities in terms of where they're going to plant. We can be based at a ward-based level, which I think is really important because it allows councillors to understand what's going on in their wards, but we can also go down to an even smaller level. So we can go down to sort of what is called an LSOA level. One of the things we can do is if you've got the right data sets and you can provide that data to us, we can start to remove things. So I think a lot of early studies looking at canopy, and I did some of the early work back in Bristol when I worked there about 15 years ago, we didn't have a lot of data that was geographically based. And we didn't have a lot of data that was GIS based. So if you have the right data, what we can do at an early stage, we can take out the areas that you're never going to plant. So if you're never going to plant on a nature conservation area, then actually having it down as a potential area for your target isn't a good thing to do. We can also start to go down, looking at ONS stats to LSOA areas. And I think this is really important in terms of getting down to the nitty gritty in terms of if you're going to start to set canopy targets and where you want to plant, where do you need to plant those things? Our canopy tool also allows you to look and bring in lots of different data sets. So within Birmingham, I think we've brought in 12 different data sets. So it allows them to set political aspirations, based on things like air pollution, air quality, flooding, health rankings, and based on those indices of multiple deprivation, they can then sort of highlight which ones are important to them, and then that will help them through the map to identify where they then want to target their planting. Our iTree canopy tool allows you to then, based on those, start to set targets, and then starts to allow you to look at tree sizes. We know that larger trees produce more benefits, and so you can set the size of the tree that you want to plant. You can set your mortality rates, and then our grow tool then says how many trees you'll need to plant and where they need to be planted. We've also brought in iTree calculations, so you can start to see, the monetary benefits of what those trees are going to do in terms of carbon capture, stormwater runoff, and other iTree features. The grow report's also very detailed, so you can even get down to ward-based or LSOA based, and you can start to see what the differences it's going to make. So you can start to map canopy within existing wards or LSOAs. And again, at the moment, we're now working to look at putting in multiple different tree sizes. So that's kind of the next iteration of where we're going this. But what this has allowed the Birmingham Tree people and Birmingham Council to do is it's allowed them to start to undertake ground truthing and start to generate 5-year planting plans based on political priorities and where the tool's telling them is best to look to plant. You can also go, and this is what we've done a lot in the States, actually. We haven't done it here yet in the UK, but we're talking to clients at the moment about this, is we can actually go down and we can start to analyze and even start to put dots on screens to start to look at how many trees. Now, all right, in reality, you're probably not going to plant that entire green space, but it just sort of starts to show that, you know, you can start to look, depending on tree sizes, where you can start to plant. What I'm going to do, though, is I'm going to quickly now jump to the actual live talk, because I think this is probably more powerful to show you, so bear with me a second.
Yeah, thanks, Russell. Live demos, I'm liking it. And you've got a few good questions in the chat, yeah, but there we go, great.
Okay, so why is that not working? Let me just stop that and try again. I'll go in a second. Okay, can you see that?
Yep.
I can't now. What is that?
We can see Birmingham's urban forests and accept all cookies.
Okay, let me just bear with me. Right, there we go. Yeah, okay, fine, there we go. Okay. So what we've done with Birmingham is we've done a community engagement map for them. So this allows them to start to show to members of the public different types of trees. It also allows them to start to show some of the iTree eco benefits. And then they can also start to bring in canopy mapping. So they can start to show ward-based levels. They can start to allow people to start to look at their canopies. So they can start to look at sort of possible planting areas. And it's quite, you know, visually good for people. And then if you then go to a,
Are some of these available to all of us, or are
yeah,
they?
so Birmingham has decided these are available to people, to everyone. So basically, I can share the links afterwards, and basically you can go in. So yes, what you're going to do here is you'll come in, you'll click on Canopy. It'll start to show the city in terms of what the Canopy data is. Bear with me a second while it loads. So here you can see we've got ward-based. You can show existing canopy by ward, or you can show possible planting areas. We can switch to the LSOA, which is this smaller local super output area, which is sort of up to sort of 1,000 to 1,500 people. We can start to say, okay, where are the areas which have our least current canopy cover? So if we just move this slider down, you can see that different parts of the city are disappearing. We then move through to the plan, and what we've done is we pulled those forwards, and this is where we were talking about those different data sets we're bringing through. So you can look at, you know, where are impervious surfaces, where is our air quality? So that's been pulled from local data sets. So as a city, should you decide to say that actually the thing that's really the most important to us is our air quality, and urban heat island is also a big issue, as is stormwater runoff. So those are the three things that in the next 5-year cycle, that's where we're going to target. And what we've now got is areas of red are the areas where you should be looking to target in terms of your planting. Then if you move through to the grow tool, what we can then start to say is, okay, based on those, I want to increase my canopy target. I want to plant large diameter trees. We are going to lose some because of vandalism, but you know, if we invest in our trees, then it should be quite low. Whereas if we don't water our trees, maybe our mortality rate is a lot higher, so it's going to cost us a lot more. So if we then apply that to the visible, we can start to see here in terms of the number of trees that's been grown, and you can start to see the model ecosystem benefits of those in terms of air quality, etc. I think this is quite, on the feedback we've had from the different clients, this is quite powerful, because we see a lot of planning applications coming in where they're looking to put in these small diameter trees. Okay. Now, if you think of it in a city, you're probably putting in a standard. So if we're saying plant large canopy trees and we want to go to a higher canopy cover, we need 60,000. If we suddenly switch to a much smaller tree, suddenly in terms of the number of trees we need to plant to get there, you know, you've gone from 500,000 trees. So it's a significant number. Now, a standard tree costs the same whether you're planting a birch tree or planting an oak. So actually, we think this is a really important tool in terms of helping councils, talk to planners, talk to landscape architects about maybe we should plant less trees, but we should find more space for them. And I guess it kind of follows on from some of the earlier work that TDAG has done. But yeah, I say we think this has been really powerful, and we've kind of been rolling this out across the UK. Birmingham was our first UK case study. We've just signed Eastport Talbot, who are now working to be the first one in Wales. So yeah,
Russell,
that's it. I'll take some questions.
well, I was going to say, if I don't know whether you had more, you certainly have quite a response in the chat. So
Oh, right, brilliant.
And really well done for a live demonstration. I'm going to take this also back to the team at the Geospatial Commission for a really good example of creating visual impact and simple user interfaces, which I do actually think, things like some of the comments in the chat, is understandable by lay people and not just the
I think it has to be. I think some of the issues with some of the initial iTree ecos is they produce nice, big, hefty, weighty reports, but councils couldn't understand them. And we've seen this with highway colleagues that equally tried to, monetize everything and then struggled.
Yeah. So have you had a chance? Obviously not yet, but if you want to have a look in the chat, but I'll read one out. But to start you off, is your calculation species specific in terms of carbon capture from planting through to maturity?
It's a overall generic based on tree size. We are moving to try and have more of that data pulled through as iTree produce more information as well. And as I say, we're about to move so that rather than the moment we have to kind of pick a size of tree, the idea is you'll be able to have multiple sizes of trees and it'll be able to tell you how many to plant in different sizes.
If you go up, Hannah Walker from Forest Research, if you scroll up, that's quite a specific question.
How accurate is iTree regarding carbon sequestration? I assume the data is not accredited, so cannot be used for offsetting. So I'm actually working with a startup at the moment looking at carbon capture, and that's an area that we're starting to look at. So, I mean, there is more work to be done across the whole iTree suite in terms of UKizing the data. I know that Forest Research and Tree Economics have done significant amounts of work to UKize data, but we can always do better, Hannah. So, and I'm also now talking with quite a lot of bankers and people that want to get into this area. And so, yes, we're not quite where the carbon code is yet in terms of woodland carbon sequestration, but I'd like to see us going there in terms of urban stuff in the future.
And there was another Hannah that I actually looked at first, Hannah Walker, if you go 3 up from there, talking about iTree Canopy or AI, which I don't know what those acronyms mean, but I'm sure you do. And if you can so maybe spell that question out.
So it's AI using different data sets. So with the Birmingham project, we've used the Blue Sky data as the base map. We've pulled in data from OS OpenReach in terms of to try and remove some of those areas of, we're not going to plant. Whilst probably I'm not a big football fan, so probably I wouldn't mind planting on all the football pitches in Birmingham. I'm sure there'd be great uproar across Birmingham, and many ward councils wouldn't have been happy. So what we've done there is we've used the OS data to pull out, cricket pitches, bowls, lawn bowls, greens, and all that kind of stuff to actually to allow them to see what is realistic. There's no point in saying that you could plant these areas when in reality you're not going to, because you just set yourself up to fail. And did you recalculate the benefit provisions, or are those? They are being pulled from the iTree Canopy tools in terms of the benefit provision, but they are UK data based because that work was done to UKize that monetary figures.
You've got a few more towards the bottom now. Biodiversity benefits. Yeah, so take a couple more there. We've still got.
Okay, so the local authorities are being encouraged to produce tree and woodland strategies, and are needing to answer the question, what have we got? In the first question, knowing what you've got is good. I think this is really important. I think, we saw recently Gloucestershire Council that basically set a target to plant millions of trees. It was adopted 6 months later, and then councils then realised they didn't have the land to plant it on. And that's what we're trying to stop. I think this is why, Birmingham are very keen to work with us, because they don't want to be setting targets you can't reach, because, that's just not good for anybody. So agree with Can. can it be used to predict canopy size increase from an individual tree? No, so our tool is based around the final size the trees are going to grow to. At the moment, we are going to start to do more data looking at sort of other information, but what we're basing it on is getting to final sizes. And I guess a few people are talking about survivability. So you saw within there was a mortality rate, and I think this is really important because a lot of people are still not investing significantly in watering and looking after their trees. And what we can allow you to do is by putting in that mortality calculation, you can start to say to councillors, well, actually, you know, or housing associations, whoever, we need to water. If we don't water, then we're going to have to keep coming back and replanting, and these are the overall costs. We see far too many planting schemes going ahead where trees are put in and they're just not being watered sufficiently to get them to maturity and get them established.
Can I just jump in terribly quickly and ask a question? I was just picking up Mark Enzer's question and Daisy Bressington's question, given that we're also now worried about tree health, as to whether satellite data can help show the level of tree health, because that's kind of defeating us. Every time we try to plant, we've got this sort of two-way problem.
I think that will start to come in. I think it's an extra data set that will start to be brought in. And I know that some ongoing research that DEFRA is doing more in the rural areas looking at that forest health. I don't know if they've done any work yet in terms of the urban environment.
Super. The conveners and chairs and hosts will have a bit of work in capturing some of the interactions here. But thanks a lot, Russell. Really good. And we're now going to go further to Phil from Treezilla and the Open University to tell us about your work. Good morning.
Thank you very much, Holger. Let me just share. I haven't been enabled to share my screen, so could somebody let me do that? Give me the power.
Let me see if I have that power.
Do you have the authority, Holger? That's the question.
No, I don't see that.
Hi, Phil. I think I've just enabled you to share your screen.
Okay.
It's Emma Ferranti.
Thank you. Thank you. Excellent. That's, oh, hang on.
It might just take a couple of seconds to kick in. Also, someone asked what NDVI is, and it's a measure of greenness that you can calculate by comparing satellite images. And so it can be used to kind of detect tree health, I guess, because trees which are less healthy will be less green. I can see your screen now, Phil.
Fantastic. And can you see the bit,
super.
The presentation version that you're supposed to be seeing rather than any kind of Microsoft preview sort of thing? Brilliant. Okay, thanks very much for inviting me to come and talk. I'm going to talk about building the monster map of trees, Treezilla, and a project that we're currently involved in with a whole bunch of collaborators called Branching Out, which uses Treezilla and does some other things as well. The history of Treezilla is reasonably, well, we're about 10 years into Treezilla as a project, and it's involved lots of different partners and organizations and funding sources as well, and some of those are pictured on the bar at the bottom. So I'll acknowledge those or give a nod to those now, and then I'll mention some specifically in a minute. So I'll cover, I suppose, a bit of ground that has been gone over a little bit by previous speakers, but maybe with my take on it and the kind of Treezilla ethos on it. So there are some figures, and I'm sure you'll know that these are very kind of ballpark, hand wavy, back of an envelope figures as to the number of urban trees that exist. That may be around 1.5 billion. Those that those are mostly probably in small urban woodlands, and so of individual trees that sort of stand alone, there may be 150 million of those. And of those, a complete guesstimate, and I would really hate for this information to become one of the dreaded zombie statistics that that nobody can trace back to its extremely unreliable source. So as you're listening to this is my complete guesstimates, that there may be 120 million public trees, and a guess that maybe a third of those are documented by local authorities. But the point really to make is that when the Treezilla project started, hardly any of that information was accessible to the public. So there's a little blue dot there, and that little blue dot in reality would be a lot smaller than that if it was in proportion to the number of urban trees altogether, and certainly those that were in public ownership. And so that really sets the scene for Treezilla, which makes more sense. The silly name makes more sense, at least with its strapline, the monster map of trees, which aim to engage members of the public and organisations in mapping, measuring and monitoring trees across the United Kingdom and also Ireland. And that was really in an aim to, or with a view to increasing engagement with urban trees amongst a broader range of people, and also trying in some way to address that very obvious data gap, and not just in gathering the data, but in gathering the data in a way that members of the public could interact with. So a second aim was to build a UK-wide database of trees, and with a particular focus on urban trees, and one that included the key properties of location, of course, as a map, but also species, which is a critical piece of information, as several of the questions that have been coming forward so far have been asking about species level information, and that's obviously critical to understanding the sort of baseline condition of urban trees, but also then forecasting responses to climate change and things like risk from novel pests and diseases. But we also aim to gather additional data on condition of pests, etc. And again, there's been some talk about natural capital, and I suppose that over the last 10 or 15 years has become a dominant way that environmental decision making, or that the policy has been set in terms of environmental decision making. And I haven't written it down, but I suppose my slightly anarchic take on that is that it feels like ordinary people, members of the public, don't have a lot of opportunities to understand and learn about natural capital, and particularly ecosystem services as a component of natural capital, and to sort of take ownership of that. And so one purpose of Treezilla was to introduce members of the public to this concept that was driving a lot of environmental management around them, and allow them to engage in that as well. So to engage in ecosystem services and the valuation of ecosystem services, and to interact with that agenda. So a short history of Treezilla that's probably not of enormous interest to folks here, but it was launched after a good deal of pilot work by my colleagues at the Open University before I started there, and funded by the Wolfson Foundation. And it started out as a partnership between the OU, Forest Research, and Tree Economics. And I picked up in 2015, where we secured some funding from the Natural Environment Research Council, NERC, for a project that we called Vital, that was to upgrade the platform and expand the database and increase engagement with a number of different partners. And so we worked with some national and local partners to better understand the sort of landscape for collecting tree data, for crowdsourcing tree data. And it became clear at that point that there was a great opportunity to use existing data from local authorities to populate a map that then could be picked up by citizen scientists. So that was the major thrust of work from then on. And again, we were fortunate to secure some funding with a project led by Forest Research that we call Community from so funding from the Geospatial Commission, and that allowed us to revamp the platform. So we took it from a platform that was called Open Tree Map, developed by a US organization. It allowed us to develop with our partners Natural Aptitude a new platform that had a number of technical improvements and was more accessible, improved apps for Android and iPhone, and also to expand the database to over 1 million records. And another important initiative that was part of that community project was the development of the individual tree data standard, which has subsequently been published by Forest Research, and you can find on their website, and perhaps one of the FR team will post a link to that. And that was really trying to address this issue that we came across in aggregating existing records, that the way that tree data have been collected historically have been very disparate, and there's been a good deal of inconsistency. And so that data standard was aiming to lay the foundations for future data to be collected in a more standardized way. Treezilla's role in that, or part in that, was to align with the individual tree data standard, so that members of the public could start to contribute standardized data. So what is Treezilla? Well, Treezilla is the UK's largest open tree map. And by open tree map, I mean a map that people can both access the records, the individual records from, but also can contribute to. So it has a present over 1 million records. It has more than 2,000 registered users. More than 600 of those are active users. So that's people who have signed up and or added a tree in the last 6 months. So beyond that, it's a platform for citizen engagement. So it's a website that anybody can access, and is designed to be a kind of friendly, easy to understand platform for people to work with publics that may be their stakeholders or their groups, or for individuals as individual citizen scientists to pick up. It's also a resource for learning about trees. So we see it as a tool for people to find out about what is around them, but also there are some resources that I'll point to that we developed as part of the community project on the site to support people to learn about urban trees. At its base, it's a tool for recording trees, and it's a tool, again, that anybody can pick up. There's no cost. You need to sign up, but that has no implications, and we don't spam you with any email or anything like that. That's just to allow you to add trees to the database. As I said, importantly, it's a standardized tree database. The records that are in there are standardized to a consistent species list, and aiming to match the individual tree data standard specification. It can also be a platform for collaborative surveying. So if you have a team of people, then you can use that to coordinate, and you can use the platform to coordinate yourselves to go out and survey an area as a group. It includes a basic analysis engine for calculation of ecosystem services. based on individual trees and the valuation of those ecosystem services. So at its heart, Treezilla is a simple mapping platform and tree database. That's the sort of key thing behind there. And as I've said, the data fields are aligned to the individual tree data standard, and the asterisk in there is that they were developed to align with the draft version of that standard, which has subsequently been published. And so part of the work that we are going to be doing over the next 12 months is aligning to the published version of that standard. This is what it looks like. So sorry, I'll go back. The map there is what it looks like when you go to the home page, and very deliberately we've kept any kind of corporate branding off the home page, again because my feeling is that that one of the things that we can do is provide this as a resource for others to adopt as their own. So my preference is that people see this as their thing rather than our thing, and can contribute to a kind of a combined effort that isn't particularly associated with any particular organisation, though the kind of project partners lead it. So simple things that you can do with Treezilla is filtering by species and location. So here are all of the English oaks that are in the database in Milton Keynes, and the different colours of the dots reflect the state of the data in relation to the individual tree data standard. So red, in fact, I'll mention what the dots, how the dots relate to the data standard in a minute. And just to flag up that those selections also then allow you to calculate for a subset of trees, the number of trees, of course, and then some of the ecosystem services valuations. So you can view for individual records the record status, and so that's one of three statuses: either red, needs updating, so it's an old or an incomplete record, or a substantially incomplete record. Good, that it's so it's amber, or orange, it's relatively recent data, and the data are relatively complete. So we've defined some essential data that that are required to determine a good status, and then excellent, so that all of the data fields are filled in, and they've all been completed within the last 5 years. And here's an example of an English oak on the Open University campus, and the calculation, the sort of headline calculation of the ecosystem services benefits. Within Treezilla, the ecosystem services calculations are based on iTree, so they are simplified equations from iTree Eco that have been translated to a UK context, and I'll attach the sort of standard health warning to the numbers here, that these are ballpark figures and I guess averages as well. So they represent expectations from typical trees of this size, or typical trees of a particular species and a particular size. But they are species specific for the most common trees, and then relatively less species specific. Am I running out of time, Holger?
Phil, no, you're not. I was just giving you the heads up that you have a lot of interest and very interesting questions. If you fancied, you could take some of those, or you just go through the rest of your slides and then answer them in the chat. But there are some very interesting and some detail, but some general questions you might want to choose to do in the next 4 minutes.
Okay, I'll tell you, I'll continue with the presentation, because I know FR colleagues are steeped in Treezilla almost as much as I am, so they may be able to pick up on those, and maybe if I scoot through, I'll get to the end. And the important thing to flag here is a couple of things. Firstly, that to get a number, And again, with the caveat about the sort of precision and reliability of those numbers, only requires the location, species, and a measure of the trunk size. And we focus on the regulating services, so water, carbon dioxide, and air pollution are the ones that we currently use. So there are some resources that we've developed specifically in the site. There's an ID guide to the 50 or so most common urban species. So we interrogated the database and as to what the most common species are, and about 95% of the total records belong to these 50 odd species. So most urban trees are covered by this tree ID guide. And then there's a slightly technical, but if you are familiar with trees and tree surveying, then not too intimidating how to survey a guide that focuses on the individual tree data standard. But the outcome is still there's only a tiny fraction of urban trees that are in open maps. So there's the Treezilla mission is sort of there and ongoing, and I'll be very interested to talk with people about how collaboration can help support that mission. Acknowledging that the sort of a bottleneck at the moment is the capacity of the Treezilla team, which over the last 2 years has, it's fair to say, been hit by the old pandemic and associated things. So one way that I think we can make that little blue dot bigger is by collating existing data sets from local authorities and mapping them to that consistent data standard, and then supplemented that with input from citizen scientists, and then working towards improved collaboration between citizen scientists, which may be formal groups or informal groups or individuals collaborating with local authorities. So I think that the kind of engagement opportunities that the amazing visualizations that Russell showed could really provide a gateway to those sorts of collaborations. So I'll talk in the last minute on the branching out project. And that's part of a set of 6 projects that are funded under the United Kingdom, the UK, what's UKRI? Research and Innovation, I forgot my acronyms now. Anyway,
UK Research and Innovation.
Yes, the research, so the UK Research Councils have funded a big £14.5 million 5-year programme called the Future of UK Treescapes, and branching out is one of 6 projects. It's led by Loughborough University, Prof Mike Wilson, and includes the University of York and the OU as university partners, and Forest Research and Ecological, which is a consultancy, as other partners. And the idea with branching out is to really consider beyond, the value of trees beyond the sort of regulating services and the other kind of physical services, and that we currently focus on in Treezilla, and to consider the social and cultural values of trees. So a completely different dimension of value in trees. So these are the current Treezilla values. And the question for the project team, which is a much bigger thing than just Treezilla, is really to consider how we can measure those social and cultural values. So we have a number of approaches that we're going to do that. So a series of participatory methods, co-production with a variety of publics and individuals and organizations, that's led by the social science practitioners and specialists within the wider project team. We're also employing storytelling, which is where the team from Loughborough come in, a methodology that they use for engagement and capturing information, and that information from a diverse range of people. And our bit is really on the mapping, where we are going to work with colleagues at York on some computer-based historical mapping. And then our OU team doing hyperspectral, high resolution remote sensing, and and incorporating Treezilla into some on-the-ground surveys. So we've established, or we're establishing, what we're calling urban tree observatories in 3 focal cities: Cardiff, Milton Keynes, and York. And these are going to be plots on the ground that are representative of the variety of treescapes in those cities, that will coincide with high-resolution, hyperspectral remote sense data. And I'll wrap up. Where we will collect extremely detailed data through Treezilla to map trees, and then relate to remote sense data to derive improved measures from remote sensing of urban trees. So we'll combine those with our social and cultural values and the framework from that to produce new maps and approaches for understanding the social and cultural values of trees, as well as mapping them. So we aim to produce some social and cultural value maps for urban trees. An ambition that, who knows if it will be realized, is to produce a CAVAT-like assessment from remote sense data based on some of the physical attributes we can extract from those data, and understanding these social and cultural values. And then to incorporate social and cultural values within the Treezilla platform. So that is both by allowing people to add those to the platform, but also reflecting the values, the kind of general social and cultural values of individual trees and species back to users as they view data within the platform. So that's it.
Yep. Very good.
So if you there's websites if you want to go and see, and that's it.
Thanks, Phil. You have now eaten up the 7 minutes you had to answer the question. There are seriously a really good reaction, and I loved one post up right up the chain. Someone saying, "I'm going to provide some technology that can make all these maps talk to each other." And yeah, that seems to be an emerging challenge. Lots of questions you've got about licensing, exporting, how you validate data, how you get data in and out. And so yeah, take a look and try and answer some of them maybe directly or in the chat as a whole. So
I'll do that.
Yeah, and thanks a lot. It's super stuff. And 230 people tried to log on to it at the same time. So that was an interesting, challenging situation for the website. Cool. So Jerry, to take us through to the break, we had a comment up in the chat about no open maps and open source projects represented. So pleased to introduce Jerry Clough from the OpenStreetMap. So
hello, hello everyone. Thank you for having me. I'm just going to see if I can share my screen, and then I'll start properly.
Yeah, whilst you're doing that, in the chat, I agree. I'm also excited about the discussion. Sometimes it might be helpful if you ask a question, because we've got so many speakers now that you actually address the question to a particular speaker organization. So we have a little bit more order in the thread. Are you good to share?
Hope so.
Yep.
Everyone see that? Good.
It's a black screen. It's a black screen for now. It's coming in now. Yep. You ready? Good to go.
Good to go. Okay. My name's Jerry Clough. I'm an OpenStreetMapper of some standing. Historically, I'm trained as a biologist, but spent most of my life as a business consultant. And 20 years ago, I knew nothing about trees, as I'll come on to. Just a quick outline of what I'm going to talk about. I'm going to say where my own interest came from, because that's going to affect some of the things I say. Talk about trees, which in OpenStreetMap are largely trees outside of woodland and probably mainly urban. Why people map trees, how people map trees on OpenStreetMap, how one might use OpenStreetMap data, understanding that data, and some conclusions. Now, I'm assuming most people have some limited familiarity with OpenStreetMap. If anyone does not, please can you say so now? Okay, I'll take that as a given that most people have some idea about OpenStreetMap. If not, more will become available, more will become obvious as I continue to talk. So my own interest in trees started about 20 years ago. I'd taken up bird watching, and someone said to me, look, that the siskins are in that alder. And I feigned comprehension and looked vaguely in the direction and realized I didn't have a clue what an alder looked like. A couple of years later, I got involved in a local birdwatching group which ran a small meadow, an orchard in Zurich, where we had a couple of working party days where we tidied up the meadow and pruned the orchard trees in the prescribed Swiss manner. And when I came back to the UK, I valued that experience and got involved in my local nature reserve, Attenborough in Nottingham, or on the edge of Nottingham. And I found that my knowledge of other wildlife, and particularly trees, increased greatly through volunteering on a nature reserve. The map on the left of the screen shows my earliest effort to do some tree mapping, which was, I've pottered around Attenborough on about 5 different occasions, an hour a bit each time, mapping all the oak trees, which are quite rare on Attenborough. And I was in particular interested in finding plant galls associated with particular oaks. And so I wandered around with a GPS and a tape measure and collected data on about 100 or so oaks. Although one of them, the one in the middle of the water, is on a small island. I persuaded the ranger to measure that one. More recently, and on the right-hand side, you see a picture of a newly discovered plant gall on silver maple. And someone found these along the Lee Valley in London in 2016. I happened to be in London, and I made use of the London data store tree map to locate a couple of silver maples in Camden. Not very successfully, because the first one I looked at had been felled and the second one had been pollarded. But fortunately, I did find it a bit later along the Regent Canal. And I later used my own knowledge of trees I'd mapped on OpenStreetMap to locate it in a mews in Paddington and in Maidenhead. So those are how I use tree mapping. I use it to locate particular kinds of insects, fungi, associated with particular trees. And I'm interested in trees themselves anyway. OpenStreetMap is 18 years old. And it now has about 18 million trees and 1 million avenues of trees, which are mapped distinctly as just a linear line rather than individual trees. There were about 190 trees mapped in mid-2007, which is the earliest I've been able to go back to. And you can see on the right-hand side, the fairly regular growth with one curious anomaly where 1 million trees or so were added in the space of a couple of days, which I'll come back to. One of the things is that the map on the main OpenStreetMap website has always shown trees, or at least since 2008 when I started. And in that time, we've had extensive discussions on how best to represent trees and woodlands on that map and on other maps. And those are ongoing. In the UK, we have about 1 million trees, which sounds pitiful in comparison to the 1.5 billion mentioned by Phil, but still not to be sneezed at. Worldwide, it's the third most popular individual object mapped on OpenStreetMap after buildings and house addresses. One thing about OpenStreetMap, and this graph shows it very strongly, is OpenStreetMap has always been about doing things on a small local scale, which is of immediate value to the people doing it. And gradually that builds up into an overwhelming set of data which can be useful to lots more people. A good example of what's happening there is a lot of UK OpenStreetMap contributors are cyclists, hikers, and so on. And a few years ago, Amazon Logistics started mapping driveways to enable better planning for their delivery vans. And in the past few years, they probably added 500,000 driveways, not only of their customers, because obviously that's what works for them, what's good enough rather than systematic mapping of driveways. And there are many other major companies making use of OpenStreetMap in similar ways. So why do people map trees? Well, one of the biggest drivers is just that people love seeing lots of detail on the main map. This is the city of Woodstock in Ontario, north of Lake Ontario. And all of these trees in gardens and on streets have been lovingly mapped by scrutinizing aerial imagery by one person. And I don't quite know how many trees are mapped in the city, but it's several tens of thousands. More typical, people map in local neighborhoods, particular square parks and squares, where they can collect more detailed information. People have mapped trees for shade analysis. Some humanitarian mapping looked at fire risk of crowns close to each other. The tree in Africa, which was very prone to fire. They're useful if you're doing 3D modeling and visualization of simple 3D models of cities. I often map trees in the countryside in hedgerow standards because they're very useful if you're walking for locating styles and things, because if you can see the style is adjacent to a tree, or there are two trees in the hedge to the left of the style, you can find it. There's always been a particular interest in mapping of plaques and memorials, and obviously there are very large numbers of memorial trees. In Nottingham, we have the enclosure oak, planted when the city's open lands were enclosed in 1845. My own interest, and that of other people, centers around the botanical and natural history implications of having good data on the location of trees. And there's a big scope for using such data in education, tree trails, tree walks, etc. And just for personal projects such as my oak mapping. You can also use it for make maps, and OpenStreetMap can be used as a base tree register for local projects. It's something which is rare, but it comes up quite frequently in discussions. And I think I'm aware of a couple of examples in London. Hanwell Community Orchard comes to mind. I just included one example of a detailed park because I wanted to show this gorgeous jacaranda in Buenos Aires. This is in central Buenos Aires, and these are fairly typical of someone mapping an important open space which is high community value. How do we map trees? I've mainly talked about people mapping from aerial imagery, which usually just gives a position, and in the past has been fairly inaccurate, but that may be improving as we have access to higher quality aerial imagery. I think more usual is ground survey, just wandering around with the GPS, waypointing trees, perhaps using the laser rangefinder and a notebook, a lot of photography. The pictures show us mapping after a OpenStreetMap conference in France 5 years ago in Avignon. And there we were using something a little more sophisticated because we were using RTK differential GPS to get resolution, centimetric resolution of the location of this particular tree. The other common form of incorporating data into OpenStreetMap is to import tree registers, usually city tree registers, which are released in a format, in a licensing format suitable for OpenStreetMap. I won't go into the details. And more recently, combinations, using a combination of those techniques. Just quickly talk about the Birmingham street trees, which is a bit ironic because they've already been mentioned. Data quality in tree registers is often not as high as one would like. The most absurd example being an 800-metre high tree in the Belfast tree register. But I had a chance 6 years ago to actually sample trees in Birmingham. I had a hospital appointment in Birmingham, and I managed to look at 180 trees out of the 18,000 street trees in 2 locations, centre of the city and around the university, and found issues with the attributes I looked at. Some of them were fairly obvious. The tree had gone, incorrect taxa, not infrequent, probably because of drop-downs when people are entering data. And a slightly bizarre thing, about 50 or 60 trees had university tree tags, not Birmingham City Council tree tags. So all imported data really needs to be gone over before pulling into OpenStreetMap. Otherwise, there's a risk that you're not you're not really incorporating data of adequate value. In terms of what gets mapped, I've tried to divide things into 5 levels of detail. There's basic positional information, which is just latitude and longitude of the tree. And this can also be a tree stump or a tree row. Some people map them as areas, but that's not particularly useful, but exceptions do exist. About 16% of the trees actually have leaf type, which is evergreen, needle-leaved or broad-leaved, or palm, I think, and leaf cycle, deciduous evergreen, which are useful tags because they can be collected by anyone. 6% have a botanical identification, and there's a range of ways of doing that. 3 to 4%, which surprised me, have some physical data, and 1% have other data, which might be planting date, dedication, identifier from the tree tag, structure, etc. So to conclude, there's a very long tradition of worldwide tree mapping on OpenStreetMap across all continents. There's a rich set of attributes available. There are reasonably well-established best practices for both mapping and importing, although they're not codified. And data tends to be predominantly have an urban focus. It's best used at a local scale, extremely patchy at a national scale, and therefore not comparable to things like the Blue Sky product. And it's very well suited to a range of different specific projects. The Osm philosophy, the incremental, we can always improve data, and collecting data which is good enough for any particular task is important to bear in mind. And something which is underappreciated, because our OpenStreetMap is now a worldwide community of long-standing, it has a very rich technology stack, and the persistence of data can be very valuable for short-term projects, particularly academic projects, which would otherwise not have funding to keep websites or data sets available. I'm more aware of that in the digital humanities, where people mapped addresses in Edinburgh for local historical purposes. There's a lot of scope for future improvements. There are recent suggestions about more detail in the cartography, which would encourage people to collect more data. And there are a range of purpose-built apps which enable people to add data to existing map trees. So I think I'll stop there.
Yeah.
There are some additional resources. I'll put a lot more into the chat in a short while. Thank you very much.
Superb, and again, good timekeeping. You've also had quite a few comments and questions. Some people have been answering as you went along. On again, questions on how to access and interoperability between one and the other resource that we've seen today and OpenStreetMap. So maybe you can take a look at that in the break. As the chat has already indicated, we are now taking a break to get a cup of tea, coffee, or answer some emails. And we will see you all back here at 11 to continue with emerging maps. So thank you, Jerry, and see you all in about 13 minutes.
Okay, thank you.
11 o'clock is UK time, so 13 minutes from now. Bye-bye. Okay, as we're all coming back from a break, I am just going to leave up that slide for a few more seconds. The next speaker will be Ben, if you can get ready. On the slide there, you can see the aims and objectives of today. One was to identify existing and emergent tree maps, and also seek collaboration between the various projects. And I think we're 1 hour in, and we're already doing quite well on getting a list of and a good appreciation of initiatives, and also lots of talk about collaboration and getting the data to interoperate and to work with each other. So very good. I can see Kevin, and on the program it says Ben. Have I missed something here, or are you instead of someone?
I'm not sure what program. The program I've got, it says me and Ben. But I'm
sorry, it does indeed. I'm so sorry. I'm so sorry. Dr. Kevin Watts, Science Group Leader, mapping trees outside of Woodland. Sorry about that, Kevin.
It's okay. I just thought I'd look at the wrong program. No, it's great.
No, all good. All good.
Okay, I'll share my screen. Is that working for everybody?
Nope, not yet. It sometimes takes a little.
Do we have to take something off?
Oh, that's me. Apologies. Here we go. Well done. Thanks, Sue. Good to go.
Is that working?
Yes,
Yep.
I can see your slide now, Kevin.
Great, great. Well, yeah, thank you ever so much for the invitation to come and talk about some of our recent emerging work on mapping trees and hedgerows outside of woodlands. I'm Kevin Watts. I'm the Science Group Leader for Land Use and Ecosystem Services at Forest Research, and also a landscape ecologist. A lot of this work draws upon some skills and expertise of my former Forest Research colleague, Maddie Grady, and also my colleague, Ben Ditchburn, who apologises he can't make this meeting today as well. So just a bit of context about this work and where it started from. And just to say that I'm not an Earth observation specialist, I'm a landscape ecologist. I'm particularly interested in the impact of habitat loss, fragmentation and biodiversity, and the aspects of connectivity, restoration, woodland creation going forward, about how we can look at fragmentation, how we can model connectivity, how we can target and understand the benefits of future woodland creation to benefit biodiversity. A lot of this work is linked by the Lawton principles about creating bigger, better, more, and joined up habitats. So we're trying to understand that aspect. So mapping all the woodland assets we have is really quite vital for that, not just the National Forest inventory polygons that we use quite a lot of the time. A lot of this work was driven by a research need as part of this project called Woodland Creation and Ecological Networks, where we're looking at over 100 woodland sites created over the past 150 years, and how woodlands and how those have been colonized by woodland species across those landscapes. So a lot of the work we were doing previously was using things like Land Cover Map and the National Forest Inventory, which is a great map that's been updated and provides a spatial map of polygons of woodlands that are greater than 0.5 hectares. So that's a really good resource. But on this slide here, my study site is a red woodland in the middle, and we're looking at the site, and then we're looking at that, that site's fragmented. There's a distance between that and the nearest woodland, and there's a certain woodland resource within a buffer around that woodland. But we know in reality, when we look at the other woody features which are not mapped, such as hedgerows, linear features, isolated tree, there's an awful lot of woodland within the landscape that we haven't mapped, which can be very important for connectivity as a habitat and lots of other aspects. So then, we start to think, is that a fragmented woodland, or is it actually connected by these unmapped woody features? So initially, this was the research need to map these sites. So I started as I said before, this can provide benefits for connectivity, habitat, carbon, ecosystem services, and increasingly natural capital. So I was talking to my colleague Maddie about this a couple of years ago and said, well, can we find a way to map those green feature within that landscape for quite a large area around over 100 study sites in a robust and systematic manner, which we could use and sort of unpick that data in quite a lot of detail. So that was the start of this process. So it basically just to map these features around my study sites. So we started some work using some of her Earth observation skills, and we tried to think about what is it we're trying to map? What are the characteristics of these features? So it's these tall features, certain shapes, certain colours and or photosynthetic activity aspects to try and map these approaches. So Maddie sort of looked at this in more detail and think about the aspects of height, colour, productivity, like is it growing, and some of the shapes. Some of the shapes will be different for trees compared to hedgerows, groups of trees. There's quite a lot of aspects of that information. So Maddie started some work to look at this a bit more and use a combination of rule-based approaches with some machine learning. So you'll use a lot of existing national forest inventories or map data of what trees look like on these objects, on these data sets, and use that to try and sort of refine and train these modelling approaches to clean this sort of information up. This is a little sort of simple flow diagram. So a lot of it was different levels of aerial photography to capture that greenness and photosynthetic activity. We've heard it mentioned about things like NDVI already. We use a lot of different digital elevation data sets. Most recently, we've been using a lot of the Environment Agency open access LiDAR data, which covers about 90% of England now. So we've used a lot of that data in terms of ground height and tree height. We've used a lot of National Forest inventory data to train some of these models. And then we've sort of built it up through these models, used a lot of machine learning and these rule bases to create these sort of different aspects of these potential data sets that could be useful for our research project. So that was a basic process, and it was seen as a way to systematically create these data sets that we were after. So from this work, we started to be able to create these sorts of features. So we could, the green areas mapped there are these NFI polygons, which were already mapped. And then all the other aspects of the landscape represent these green areas in my previous slide. So there's small woodlands below 0.5 of a hectare. There's groups of trees. So that's these, smaller than a small woodland, but not quite an individual tree. And then we can pick out lone trees, be that within isolated field trees or hedgerow trees. And we're also capturing those blue areas, which are the hedgerows that over a certain size, certain widths and certain shapes. So Maddie did quite a lot of work to distinguish between the different features by their textures, shapes, sizes, and their sort of spatial configurations. So that was some of the outputs that were coming out, and that seemed to be very fit for purpose for my particular research needs. So I could say, how well connected are they green woodlands or my study woodlands? How could those other features that are mapped there benefit biodiversity moving into those woodland creation sites? So, it was quite good at picking out some of these isolated field trees, and some of these could be larger. You could pick out trees over a certain height if you're looking at sort of more mature veteran trees and understand their role as well. So we're currently investigating the value of those features on particular biodiversity taxa we've surveyed within our study sites. So that was where my sort of interest sort of drew to an end for my research need. But that was then taken up by some of them work led by Ben Ditchburn in the Natural Capital Ecosystem Assessment work funded by BIFoR. So from that, some of Maddie's work was then scaled up to create these sorts of maps for the whole of England. So that's currently being complete. So there's a map for the whole of England with these features classified to these different levels. But the key part of the work now that Ben's taken forward is this sort of the survey of those aspects and the validation to create some sort of fundamental statistics of how accurate these things are, and then further detailed surveys to refine that knowledge even further. So just on this sort of survey example here is first of all is the woodland samples. As part of the National Forest Inventory, they do 1 hectare samples across the whole of the UK. So Ben is now starting some trees outside of woodland samples at 1 kilometre squares. And that's then combined up as a grid across the whole of England to do those samples at the 1 kilometre squares at selected random grids. And then they do surveys within that, which I'll come on to. but from that you can get an idea of the accuracy of that data and some idea about the errors around different aspects of the modelling approach. So from that, Ben's termed it this idea about triple calibration. So we've gone through that's hand map samples. So within those, people can draw around with aerial photography. There's detailed field work in each of those 1 kilometre squares. And there's also then this comparison with this machine-based model that Maddie's created to start with. So that's that sort of calibration of that data, how good it is, how reliable is it, and can it be refined and improved as well. So just to give an illustration of what these sample squares look like, this is one here, it's a 1 kilometre square. So in green is the NFI map polygons. So that's what's already mapped and surveyed. Within that, we can overlay these predicted features from sort of isolated trees, hedgerows, small woodlands. So within that, these will be surveyed in more detail. Just to give an idea, so they're going to try and pick 5 small woodlands per sample square. They'll do 15 groups of trees and then 35 lone trees within those squares and a certain length of hedgerows within that square as well to get some idea about the accuracy. So that's the sort of validation and testing of that data. So this is like, it's quite detailed measurements, just some of the, I won't go through all of these, but this is some of the aspects they'll be capturing. So it'll be things about species, size, crown widths, quality in terms of their sort of their status, and some other aspects which could be really quite useful for that data to refine it going forward as well. So that's a super quick whiz through some of this data. So it's very much developed as a research project output to start with. It's been taken up from this BIFoR Natural Capital Ecosystem Assessment Funding to roll it out further as a map, but then also this follow-on field work to test it and validate it further. So that's my talk. If you want any more details about the actual, some of the science behind it or the uses of some of the tree-sided woodland data in the research aspect, by all means, email me. If it's more about the data itself across England or some of the natural capital ecosystem assessment validation work going forward, you can email Ben Ditchburn at Forest Research. So
superb. Kevin, you've also had, the chat is full. If you scroll up, you can just have a look if there are questions that you would like to,
I'll just try and
answer now.
I'll just try and
Sue's just messaged on our host chat that her head is spinning with all the different initiatives. I just want to say we're flushing out, first of all, everything that exists, and even that in its own, as the objective of this meeting is to end up with a good view of all the existing initiatives and maps. And something at the Geospatial Commission we're dealing with many other data sets across government and private sector. And we have a concept of FAIR data, which stands for finding, accessing, interoperability and reusability. And the first thing is to find. The second thing is to be able to access. And that is where quite a few questions in the chat are to do with commercial and non-commercial use, IP and licensing. And most problems can be overcome. So I encourage you to keep posting, and also not just say, it's often about really to think about who you are, what organization you are, and what you want to use it. So there's an interesting exchange there about Treezilla and OpenStreetMap. Sometimes there are hurdles in place that can be overcome, and sometimes they're just also exaggerated and are not really true. So again, I encourage you to keep the discussion going. There is a lot, but yeah, let's see if there are some questions you want to answer.
Yes, yeah, I can. I think, yeah, I agree. In terms of access, that's being explored at the moment. This was developed with BIFoR NCEA funding, and that's being discussed now. So I think that's discussions that Ben's leading on about that aspect of the work. The question about Scotland, a lot of this work was derived from open access LiDAR data, and there is openly available LiDAR data for a large proportion of England. As it becomes available for Scotland, some of these approaches could be rolled out further, so there may be options to extend that further. someone said about was scrub included. I think if it's above a certain height and it's got a certain photosynthetic activity and a certain texture, some of those aspects may be picked up. That could be explored further.
Yes, so you've got a couple of questions about access. Can other researchers access this? I think that in general, all government funded research and all government funded publications ought to be accessible to anyone. It depends then, as I said before, what the intended use is. And some, I mean, generally DEFRA has an open data policy. So yeah, be in touch with Kevin directly, but it might be that the data set is not signed off and complete. You know, there might be still quality issues, but in general, it should be.
Yeah, no, I think I certainly agree that I think access will be the big issue. I think Ben Ditchburn should be able to provide some updates as it reaches a more of a completed version.
Super.
Yeah, and someone said, what is TOW, T-O-W, sorry, trees outside woodlands. So that's everything that's woody beyond what's mapped by the National Forest Inventory.
I also love, there was someone in the chat further up that they have an inventory of rail acronyms and that maybe we need one for trees. Absolutely. This is about part of the FAIR principles is, of course, that you have your dictionaries and your lexica open and accessible and make things interoperable. There was a question, we've still got a couple of minutes before we go to, if Daniel can get ready, please. There was a question about whether the waterways are also providing wildlife and habitat corridors, whether they're included in your thinking and not just the green corridors.
Yeah, absolutely. I think a lot of the connectivity modelling that I do is very much about woodland species, and there's often major riparian woodlands along watercourses. So that's one of the big things we're trying to sort of map is those woody features along riparian systems as well. Yeah, and also just to say, you know, that this wasn't sort of a rural project or an urban project. It is basically a whole landscape project. So it will cover urban trees, rural trees across the whole gradient.
Great. So thanks, Kevin. So continuing on the theme, trees and hedges from Norfolk County Council. If Daniel is ready to take the stage.
Has Daniel joined the meeting?
Which looks like we have. Yeah, we don't. I can't see.
Yeah, he's there. He's there. He's sharing.
Okay, cool. Yeah.
Daniel's a Zoom newbie.
Right. Very good.
So,
no worries. Can you hear us, Dan? We can see your screen,
but we can't hear you.
Can you hear me now?
Yes.
Sorry about that, everyone.
No
can
worries.
You see me? Right. So you can see my screen. Can you see?
And we can see the notepad and.
Okay, that's right. Okay. Let's swap round. Okay. Sorry about that. Yes.
We're still good with time. Lovely. Are you good to go?
My name's good to go. Yep. My name's Daniel Voisey. I'm a geospatial analyst with the environment section at Norfolk County Council. Thank you for the opportunity to present the Norfolk Trees and Hedge Map. I mean, there's a lot here that's quite similar actually to what you've already seen. We call it the Trees and Hedges Map, but it's actually a canopy map, similar to what we saw with the National Tree Map, described by Ralph Coleman. You can see that, again, along with a number of the other products we've seen, this is a map of trees and hedges. When we look at this, the symbology that I've used is sort of cool to hot. So cool green features are the low hedges through to hot red tall trees. So the initial driver behind producing a data set at this level of detail was the need to assess highways tree risk, again, and a theme that Ralph was talking about. And the development of the tree and hedge map has certainly enabled us to sort of refine and focus our highways tree surveys. But also, you know, with the growing environmental agenda, which has been rather supercharged by, of course, by the Environment Act of last year, you know, there's a need to focus on analysing the role of trees and hedges, the ecological role of trees and hedges. So one of the more practical measures is, of course, tree planting. So the tree and hedge map that we have here, you know, is invaluable as an opportunity map for tree planting, and in particular in a rural county such as Norfolk, tree planting is often going to take place along hedgerows to gap up hedgerows and maybe plant standard trees along, you know, hedgerows that consist entirely, as these green features here do, of very low hedging. Anyway, so in the production of this data set, you know, we looked at the commercial products on the market, but we decided we needed a more custom product that suited the needs of Norfolk more particularly. Again, really the need to map hedgerows down to a lower level. This data has a lower threshold of 2 meters. Actually, we've produced one at 1 meter, and that really does give us a very good picture of the low hedgerows. So this data is derived from the Environment Agency First Return 1 meter LiDAR, which not only is that an amazing resource, of course, but it's also entirely free of license restrictions. So we can use this data and utilize it freely and share it and publish it without any restriction. So we've developed an open source based approach to extracting this data from the raw LiDAR, which produces a polygon data set. And you're looking at a raster version here of the polygon data set that uses open source software, Python tools, to extract polygons along with the height value from the LiDAR. And we use master map to clean the data, to remove buildings and other features that we don't want, such as power lines, etc. I mean, to be fair, there's more work to be done on that process, but we find that in Norfolk, the results, even after the first pass, are pretty good, pretty usable. Anyway, the use cases really here, I've already mentioned the evaluating tree risk on the highways. That's a big deal. Opportunity mapping for tree planting, obviously another very big deal, which others have covered already. Access to green space, again, a strong theme described by Russell Horsey. We can sample this data, you know, with other polygon data sets such as lower super alpha areas and begin to quantify and evaluate access to green space, you know, at the tree and hedge level. Other things that we can do, which touch on what Kevin Watts was talking about, you know, looking at how the network of trees and hedges in rural areas form really the fabric of connectivity in the countryside. We've begun to explore how we can use this raw data to model that kind of connectivity. So if we pull in the what we might call our sort of core habitat sites, these are the National Forest Inventory polygons of 10 hectares or above. We can perhaps look at the spatial relationship between those polygons in terms of nearest neighbor, which of course is a straight line sort of relationship. Each of these polygons, has 3 nearest neighbours, and we can draw lines to each of those, and we end up with something like a proximity network. And then we can go on to examine the nature of the connectivity that the actual hedgerows deliver using a least cost paths analysis, using the tree and hedge data as a cost surface. And we can examine the least cost route between one core site and another. And this kind of approach can help us target areas for improvement of connectivity between sites, which is a really strong theme of the recently sort of they continue to be the recently introduced idea of local nature recovery strategies. Connectivity in the landscape is a key concept, and so this is one approach that we're looking into to identifying opportunities to improve connectivity. There's another. I may have time to show you this. I find this particularly fascinating. If I can get that out the way, I can't see my tabs. There we are. One of the things that we've been looking at is if anyone's familiar with the wonderful National Library of Scotland maps, where they published the first edition Ordnance Survey. The first edition Ordnance Survey nationally marked the location of every tree in the country, which the survey in Norfolk was conducted in the 1880s. So what we're looking at here are trees in Norfolk from the 1880s, plotted individually. Obviously not woodland trees. These are trees outside of woodland. And we've worked out a way of georeferencing each of those from the map scans, basically giving us a georeference point. And then of course we can overlay that, the modern trees with that, and begin to get a sense of the trees that may survive. I mean, there's no certainty about this, but there's a probability that some of these trees where you've got blue dots and the modern polygons, some of these trees may indeed be one and the same. So we can start to think about the probability that they are, and from that we can start to develop models of veteran trees across the entire landscape, which of course, from a nature recovery point of view and from a green infrastructure point of view and a natural capital point of view, will be a very valuable insight. And finally, because I know I don't have much time, in terms of presentation of this data, the raw data actually does provide a great insight, and people like to look at it, and so we have published that to the internet, and people can peruse the Norfolk trees and hedges map freely. But of course, we're now looking into how we might present summary data, by summarizing the data down to, here we have 1 kilometer hexagons. And this is a presentation that we're working up and we'll be aiming to make public before too long.
Daniel, fascinating, absolutely fascinating. I got so immersed and I forgot to actually do my bit and hold you to time.
Okay.
Yeah,
right, sorry about that.
No, it's fascinating. And in my role at the Geospatial Commission, we're dealing with a lot of local authorities, and this shows that we have hidden gems of capability and capacity. And I just wonder whether one outcome here for me is, to increasingly to help local authorities help themselves and share capabilities and with each other, because I'm not sure whether many people around you, are you sharing this with your?
We're working at present. We're working with Suffolk County Council, and so everything that I've shown you that we're doing in Norfolk, we'll also be doing with Suffolk as well.
Really good stuff. Sorry to cut you off there, but
no problem.
thanks and keep sharing in the link. I'm going to go to Sven, who's joining us from Germany. Are you there, Sven? Yep.
Yep. I'm here. Thanks, Holger. Cool. Emma, may I ask you to share my 2 slides for me?
Yes, of course. So Sven is Director of DACH looking at nature-based smart city solutions. Welcome, floor is yours. And I think Emma was going to.
Yeah, thank you.
Perfect.
Working well. Thanks a lot. Hello, everybody. Happy to be here and part of this. So yeah, my name is Sven König. I'm a director of GREHIL, responsible for the DACH region, Nordics, as well UK. We help with our system and platform cities to amplify the impact of nature-based solutions on sustainability and biodiversity, resilience, and city and well-being. Our digital twin technology accelerates the digital transformation of green asset management. Emma, may I ask you to change to the next slide, please? Thanks. So how we do this? So GREHIL is using the latest LiDAR, AI, and machine learning technologies to capture a centimeter accurate point cloud of the entire urban environment. We heard even today a few times that LiDAR is used and is still a practice which company is doing, but what to do then with this 9-point cloud, which is captured? And here we make the difference. So with our AI and machine learning system, which we trained over 2.5 years with the first pilot project in Singapore, we are able to segment each single urban tree. And we create an exact 3D digital twin of each tree, of each green urban asset. And if requested, we can create also 3D digital twins of any other assets. You can see here on this point cloud picture. We provide then information about your urban trees, more or less at your fingertips. So we're starting with a standard tree inventory to deliver metric information. Then we set up with health status and condition, structural analysis, economic value, and ecological benefits. So for the economic value, we're calculating for the UK according covered, which is the huge covered version. For other regions, for instance, DACH, we're using Koch. We are able to provide with all the ecosystem services for each single tree and of course for the entire urban forest, as we are scanning the trees in a centimeter accuracy of ±2 centimeters. We're capturing the entire biomass of the leaves, of the wooden part. We can calculate the leaf area index, etc., so that we provide those kind of information. We see that it is important, if you want to manage something, you need first to measure it. And exactly this we are providing with our platform. So this enables you to analyze and optimize the impact of trees on the environment. You can view advanced analytics on air quality, surface temperature, and canopy cover. So we're creating heat maps for different aspects. We analyze the diversity and distribution of existing trees and compare key attributes to meet your planning goals, which is even more important today. Doing this, we are using the underground information provided by the cities and our scans to put both together to identify new planting locations in the cities. As today, a lot of planting activities existing and cities and municipalities spending a huge amount of money on this, but having less idea where to plant trees. So planting trees somewhere outside the city is nice, but having less impact on the urban life and the well-being for citizens. We scan the above and below ground as mentioned and put both together. We simulate the local impact and the return of investment of your actions, which is important on level above who creating the budgets, so giving finally the money for everything. We support also and improve the quality of urban forest and boost the efficiency in daily operations. This we measured by the system running in Singapore, as here we have long-term experience. Singapore is handling 3 million trees with this and increasing by planting another 1 million trees using the same amount of manpower to handle everything. You can do a significant faster tree inspection, so that tree care specialists save time by analyzing the digital twins, the panoramic imagery, metrics, and work history, and literally before heading into the field. So they can plan on their desks their tour outside. So for instance, we can do automatically the road clearance, height clearance, etc. Automated analytics for tree health and safety. So teams reduce amount of tree-related accidents and tree loss by reviewing an automatic generated list of those trees that may require special attention. In Singapore, within 2 years, they reduced tree-related accidents from 10,000 a year down to 400 as they moved to predictive maintenance. And all those relevant information you have in the platform available. So we call it a tree impact manager. It's much more as an inventory or as mapping trees. We have 3 main parts in it. It is the green operations, the green urban planning, and the green governance part. And I'm quite happy to share much more in detail, as well running in a separate meeting, a demo. So thanks for your attention, and I'm handing over to Holger.
Yeah, great, Sven. If we can go straight to Paul from Green Talk. We obviously have a whole hour of panel responses and wider discussion. So thanks, Sven, for your presentation, and handing over to Paul.
Great. Thank you, Holger. Let me just share my screen. So I'm Paul Wood. I'm one of the directors of Green Talk. Green Talk is a London-based developing a public-focused platform that connects environments with stakeholders. We've been particularly focused on local authorities, but we can work with any land manager and any kind of landscape. The key for us is data and the availability of data, and especially tree data. My colleagues, Rob and Steve, I hope are in the audience, and they may be able to share some links through this presentation, which will be relevant for people in the also watching. So the genesis of Green Talk is from Tree Talk. Some of you may have come across Tree Talk, which was developed in 2017 from the data that was released by the Greater London Authority of the publicly managed trees by the 33 London boroughs and the City of London. Not all of the boroughs are there, but most of them are. We took that data, developed Tree Talk as a way to look at all these different things that were happening with the trees, find out about what the species were, how frequent, how diverse they were, and so on. We became aware that each borough in London collects data in different ways using lots of different asset management systems like EasyTree and ArborCheck, for instance. And we realized that there was an opportunity to take the data from those systems and build it into a platform which became Green Talk. But just staying on Green Talk, we developed a rich interface which can have all this information about the individual tree species. We have custom summaries, which are our own summaries about loads of different species and cultivars. We have images of a vast number of specific species and cultivars too. Users can sort trees and can find them by their rarity or their commonality, for instance. We also generated walking routes. So we have a system which enables users to click on a tree and then generate a custom walking route around that tree, or it can go from A to B. So it can take you from a tree to a tube station, or it can take you from a tube station to a tube station. But the point is the waymarks along the way are the trees. So it's a way for users or the public to explore their local environment through the trees. We are able to dig into that data, and this is a way of visualizing how diverse the tree planting is in certain parts of London. You can see here as well how some of the gaps are exist. So some of these boroughs like Hackney, for instance, wasn't able to provide the data to the GLA. So as well as diversity, we can look at canopy cover and all sorts of things which is embedded in those data sets which are managed by local authorities. And what we're trying to do is make that data come alive and make it engaging for people on the street who want to find out about these things. During lockdown, Tree Talk really hit a nerve. Lots of people were using it. And this heat map shows where routes were being generated during lockdown using Tree Talk. It got a lot of publicity, lots of people came across it, and we got all these types of comments that people were telling us about as well. So we discovered that people thought it was one of the best things they found in lockdown. My favorite one, though, was that it was more fun than Pokemon Go to go out there and find gold trees or rare trees. So we categorized the trees by rarity, the rarest ones being gold, silver was the next rarest, and so on. And those were sort of goals which people could take on. So Green Talk has developed out of that. Green Talk is a platform, and we're working with a couple of local authorities, including Bradford and Hounslow in West London. On the Hounslow version, we've developed a whole load of exciting new features, which are around user engagement, care, history of the trees, and so on. So hopefully you'll be able to explore this Hounslow map, and you'll be able to find out that you can adopt trees if you live or work in Hounslow. So if I adopt a tree, you're committing to look after that tree and care for it and give additional water beyond the watering cycles that the local authority is providing, and enhance the life chances of that tree. So what we want to do is reduce the mortality rates of newly planted trees, and there is anecdotal evidence that this can reduce those mortality rates significantly by getting the population involved. Our adoption functionality is very clever. It uses weather data, so alerts users when they should go and water trees. So I think we'll be sending out alerts over the next couple of days with the 30+ degree temperatures in London at the moment, to get people to get those people that have adopted trees in Hounslow out to water them. There are also social functions, so users can start tagging trees, they can like trees, they can share those trees, they can build up routes that they particularly like, and in the future we'll be able to curate routes. So those could be curated by the land manager, or those could be curated by users, and those can be shared as well. So those could be ways to explore the urban forest by looking at the most interesting species that are around, by looking at significant trees. So what have we learned through this process? We would love to see more tree data in the public domain. We are a business, but what we do, we're respectful of the data. We're not creating data, and any data that we would create goes back to the data owner. So that would be in the public domain. We want the data to be timely, accurate, and complete. That's really essential for us. I think that what we've discovered is that the public are really interested in trees, the activity that happens around trees. So trees being removed, when a new tree will be filling a tree pit, when trees are being pollarded, and so on. And by providing that data in a timely manner, you can really engage with the public and really get them to understand what's happening in the urban forest. Accuracy is also critical. I'm getting the sense that I'm running a bit over time.
Yeah, we need to call
there we go. That's probably about it for me. I'll just put you on to the last slide. We can integrate all sorts of other data sources. We'd love to work with any of the organizations that have also been presenting today, and I'll leave it at that. So thank you very much.
Superb, and you'll be pleased to read in the chats how many good vibes you've been getting here. So thanks. And we're now going across to 3 government agencies, all part of the BIFoR family, starting off with Martin from Natural England.
Okay, thank you. So I'm trying to do the share screen. Can we see that?
Yes, thank you, Martin.
Okay, I can't get to presentation mode because it's in the way. So I'll just have to use the slides as they are. Apologies, they'll be a bit small. So my name's Martin Moss. I work for Natural England. I'm very aware we're slightly over time, so I will motor through this at breakneck speed. So apologies for the speed, but I'll try and catch up.
Martin, there is a button next to your, right above the 23 degrees. There's a button with a little, if you go next to your Zoom slider, up and then, sorry.
I get a pop-up and...
No, it's there. So stay where you were.
Yeah.
And if you go down and don't click anything, it's the little screen symbol next to the book. Yeah, that's the one.
This one.
Yep. Thank you.
Aha. Right, we're there. Okay, so I'll start again. I am Martin Moss. I work for Natural England, Senior Advisor in Green Infrastructure, and I head up the Green Infrastructure Mapping Project, which is related to the Green Infrastructure Framework Principles and Standards for England project, which is a 25-year environment plan commitment. So this project sits within a much bigger context. And the first iteration of the mapping, the Green Infrastructure Mapping, was published back in December last year. And the second iteration, version 1.2, is due for publication in December of this year. So it's very much a sort of rolling program of versions of the mapping to support both the Green Infrastructure Standards rollout across England, but this is also part of the Natural Capital and Ecosystems Assessment Programme, which was mentioned earlier. So this is part of the Natural England contribution towards that. And it's not a static product, it's all about change. The maps are a means of ways of getting to a place, and that is change detection over time and into the long term. So I'm looking to try and get onto what I call the 5-year stride, which is continual change detection. So version 1 we're putting together now, version 2 we're beginning to start, that will close down in 25. We will then compare version 2 with version 1 as we start version 3 and so on. So what we're trying to do is to understand a variety of things, including how things are changing, how our green infrastructure asset base is changing over time in terms of typology, but also where it's changing in terms of location and distribution, and in particular how that affects people in terms of supply, demand, inequalities, performance and quality. That is a journey. We can't do all that at the moment, but we're on a journey to be able to undertake that task. And I see green infrastructure both in 2 ways, really, 2 connected ways, one of which is as a socio-environmental infrastructure. In that term, it's there to do a job. So is it doing the job? Have we got the right stuff in the right place, doing the right thing? But underpinning that is a need to understand the urban ecosystem. I would sort of say that I think the urban ecosystem in this country is possibly the one we may know least about, but it's actually the one where most of us live. So you could say it is the most important of our ecosystems. And if we're not getting this one right, think about what we're doing to all the rest of them. So understanding habitat composition, conditions, species diversity is another journey. We can't do all that at the moment, but a healthy urban ecosystem, a healthy ecosystem overall, is fundamental to a healthy functioning socio-environmental green infrastructure. So what's my problem? We haven't got anything like time today to go through the mapping. So I'm just going to focus on the woods and the trees and say that I've got a problem. I'm a data user. I don't generate data. Not quite true. We're starting to do that, but I'm heavily dependent on existing data. And the woodland data in the mapping at the moment is based on combining OS, open woodlands, with national forest inventory and the ancient woodland inventory. So the woodlands element of our mapping is reasonably complete. There's a lot of data there, but I literally can't see the trees for the woods. I've no tree data. So what's my problem with tree data? Well, I have certain needs as a project. I need England coverage. I can have some gaps on the map, but they do cause problems because I need to be able to combine things and I need to be able to add them up to get the England level picture. I also need consistency in how it is created, how it's collated. So I tend to say it has to be the same in Berwick-on-Tweed as it is in Penzance, as it is in Margate. Otherwise, again, I can't add them up. it needs to be subject to periodic update. So a survey that was done 5 years ago is precisely that. I need to be able to compare something that was done 5 years later. So update schedule is important. And finally, and this is really quite often the stumbling block, the data has to be open government license compatible or capable of supporting the creation of a derived product. And this is where I've had real problems with tree data, because the best, we've heard some of the stuff that's out there at the moment, the best available tends to be commercial. There are cost and licensing issues there for me. Much as I'd love to use it, and I did try, but my budget holder wasn't happy with the cost. So the other data that's around is generally in development. We can see today how much stuff is on the way, and I'm kind of thinking in 2 years' time I'll probably have a choice of data to be able to use. But right now, right here, I don't really have a workable, or I don't know of a workable alternative that we could use for version 1.2. And we have some particular needs around the urban environment. So whilst I'm interested in, for example, trees outside of woods, in general, I'm specifically interested in the urban environment because for some of the work we're doing, we have a particular focus there. What would I do with it if I got it? There are so many different uses, but I'll highlight three. One of which is we use greenness as a measure of general environmental quality, as it were, so less green and more green areas. And this is spaces we can see here on 250 meter grid square, and it just at the moment this is derived from OS topography data, so it just gives you the percent which is man-made. But I tend to think of this is greenness at ground level. What's above you? We don't have tree data, therefore I can't compare the ground with the canopy, and it would be really interesting to be able to do that to better understand not just the overall levels of greenness, but we have a particular focus on understanding inequalities. So understanding inequalities in the outside environment is fundamental to us. I can only do it partially at the moment because I don't have trees. We're also looking at mapping various elements of what I would regard as ecosystem services, I suppose. So one of the things we're interested in at the moment, working with Manchester University, is even urban heat mitigation. We don't have tree data. The connection between being able to understand urban heat island and mitigation and tree data is fundamental. Without the open tree data that we would need, we are really struggling. So we're using land cover data, which is very far from ideal, but it's what we can do at the moment. With tree data, we can improve considerably. And then I mentioned the urban ecosystem. This is where we are generating data. So we are creating, this is pilot at the moment, a method, an Earth observation method of mapping urban habitats. And we can see there's a great long list of them here, one of which is scattered trees and one of which is garden trees. We do differentiate between these two things. So we're starting to create means and ways of being able to fill some of the gaps in the urban environment with respect to trees viewed from a habitat perspective. So this doesn't give you tree data, it gives you combined areas of scattered trees and garden trees, and trees within various different contexts. So that would help us a great deal. But we're years away. This is still a pilot. We've only got it for one city. This is Plymouth. And this is the sort of information we can start to derive from that data. So on the left-hand side, we've got a density map by LSOA level scattered trees. And on the right hand, we have woodland. So we can see that we're starting to be able to see the interesting patterns of the differences in the distribution of these different sorts of resource. So that's me. I need trees. I ain't got them at the moment, and I'm hoping in the not too distant future I will be able to say that's changed. Thank you.
Superb. Thanks a lot. Thanks so much. And again, lots there, but as we know, it's all about bringing out the sound bites from everyone today, and we have a lot to go through in the chat. So Environment Agency, Alistair. Thanks, Martin.
Okay. Hi, can you hear me?
Yeah, we can hear you, see you. The screen is your desktop at the moment.
Okay, can you see me? Can you see my presentation now? Okay, great. So
no, we can only see the desktop with your logos. So you might have this problem with two screens.
Holger, are we viewing the previous presenter's desktop?
Oh,
or is it 23 degrees where Alistair is as well? I'm wondering if Martin needs to stop sharing.
Yeah.
And I can't, I've lost Martin from my list. So Martin, you need to do.
We are still on Martin's screen.
I've just switched off. Yep.
I'm going to leave. I can't seem to find the controls, so I will leave and come back in.
Alistair, I can see your screen now. And
Can
I
you
can
see
see
it?
myself on your screen.
Okay. Can you see my presentation okay?
No, we now can see your Zoom screen. I can see.
Can you see it now?
Nope. So what we can see is your Zoom screen with the names along the top, and I now can see myself.
Okay, I will. I'll try to share again.
Yeah, exactly. No worries.
Is that okay now?
Yes, and now perfect. Go.
Is it now full screen?
Not yet. Go back to the little. Go back to the slideshow presentation thing.
Okay. This one down here, slideshow.
Yep.
There we go. Is that sharing now?
We can see the screen, but it's not going into slide mode. I don't know why. We can just see it here in the normal.
Okay. Should I just go like this with the the preview? Yeah. Okay. So I realize.
Yep. Cool.
Yep. Okay. So a lot's been talked already about our LiDAR data, which is great. We have national coverage now, national coverage for England, open LiDAR data. All of our LiDAR data is available from the BIFoR DSP, the Data Services Platform. And this includes LiDAR point clouds, raster digital elevation models, whether that's DTMs or DSMs, spatial coverage metadata, and we've also published some image service layers as well. The archive goes back over 2 decades, and many locations have got repeat surveys so you can view change. Okay, so this map shows the build-up of our archive over the last 25 years. On the left-hand side, you can see the LiDAR national coverage for the first 2 decades of our survey, which is based on project-based flood risk modelling and coastal risk modelling. We built that up over time, but only to about 75% coverage of England. In 2017, we took the decision to go for complete coverage because we had improved instrumentation, and also we had the requirements to do complete catchment modelling. Our data is predominantly for flood risk modelling, but can be used for all aspects of environmental management. And as it's open, it can be used for a number of different applications such as forest mapping. One great thing which we've been doing lately is called the Keeping Rivers Cool project. This project is to promote riparian shading along tree planting along our rivers to give more shading on our rivers, because fish like cool waters. So we want to be able to map our riparian shading. We want to demonstrate where they're shading over the rivers. We want to give strong evidence base and mapping tools to be able to give that evidence to put it into action. Okay, because we know that if you have shaded rivers, it can reduce the temperature of the surface of that water, by a few degrees, in the summer months. And as we're aware of the climate emergency, we want to mitigating effects. We want to mitigate against this in the future by planting more trees along rivers. Okay, so the Keeping Cool project, we did a first version using our data back in 2011, 2013. But that's when we only had limited coverage of about 70% of England, and we were predominantly using last return digital service models. I'll talk about first and last return in a minute. But now, we have complete coverage of England, except for a very, very small area in North Yorkshire around an RAF base, which we can't get into because of military exclusion. And so now we have better data to run a version 2 of Keeping Rivers Cool. And we want to produce the vegetation object model and riparian shade maps for use in this. And this goes towards the England Woodland Creation Offer. Okay, so difference between first and last return. You can see that the LiDAR sweeps a laser pulse underneath the plane. You get the first return from the top of the tree and the last return from the last thing that the laser pulse hits. If you see the graph over on the right-hand side there, the blue line is the first return, so that's the top of tree canopy. The red line is the last return DSM, so that might be the last solid things that it's hit. And then we do a lot of modelling and QC work to produce the accurate digital terrain model, which is the bare earth terrain underneath all the surface objects, which we use for our flood modelling. And that is what we are really interested in terms of our flood modelling. But because we have very good idea of the ground surface, you can then subtract the ground surface from the top surface, and that will then give you the object heights. You really do need to have leaf off winter flown LiDAR to get the best digital terrain models. With the first return we get from our LiDAR, you will also see the top of twigs and the top branches in a tree. Okay, so just show you some examples of how we've created our vegetation object model and our riparian shade maps. This is a little area down in Kent, the River Ine and Ainsford. There's our digital terrain model with all surface objects removed. It's a hill shaded model there. That's the next image is the last return digital surface model. So you get the impression of the surface objects such as buildings, the bridge, and also some tree stumps. Then the first return gives you a much fuller canopy. Subtract the first return from the digital terrain model, do some advanced spatial analysis work. You do some screening based on Ordnance Survey mapping and proximity to surface to features within Ordnance Survey mapping. We do a screening of those objects with an NDVI, averaged NDVI image from Sentinel-2 open data, which we calculated in spring 2020. And also we do some clever analysis of last return and first return percentage similarities within those objects and the shape and size to give us vegetation objects above with a threshold of 2.5 meters height. So each of these pixels here, the green pixels you can see, it's been classified as a vegetation object. The deeper the green, the higher the bit of vegetation is. And we've also got a hill shading effect, including the digital terrain model to show the vegetation in the context of the surrounding landscape. Just to show you a aerial photo now for comparison. This is where, so there's an aerial photo for comparison. So the vegetation objects are showing all the trees in the back gardens, as well as along the river, along the railway, and so on. Can you see me flipping between the two images?
Yes.
Good, good. We then use that data to then model multi-directional sun shading by simulating sun direction over different intervals during the daytime between May the 1st and September the 31st. We then take all those models' shadows, we average them together. We've then attached those rasters at the full 1 meter resolution to the Ordnance Survey open local surface water features. We then ranked those in a 5 percentile ranking to show you the most shaded and the least shaded river stretches. So here on this rainbow river map, the blue areas are the stretches of river with the most shading, and the orange and reds are the least shading. So the orange and reds could potentially benefit from tree planting so that in the future we would have more riparian shading, which we know that the fish like. Okay. So we have now finished this work as of last week. If I go down to next slide. Oh, just show you some more detail about that. So here on the left-hand side, you can see the individual hourly epochs of the model shade. Okay, so 6 a.m., 8 a.m., 10 a.m., 12, 14, 1600, 1800. Then we daily average that. Then we sum all of those together to give you a complete summer season shade map, okay, at 1 meter resolution. We've done this for the DTM as well as the first surface models, okay, and then we attach that data to the the OS open local surface water features, which have been split into 25 meter blocks. Okay, blue rivers are the most shaded, red rivers are least shade. You can see as well there the vegetation object model is draped on top of the hill shade from the standard digital surface model. Okay, so that's now complete for as of last week for the whole of England. So we have 1 meter resolution vegetation object model there on the left hand side, and then riparian shading of all our rivers on the right hand side. You can see that one little block up in North Yorkshire around RAF Fylingdales that we haven't been able to get into yet because of military exclusion. They have a very high power radar system there for detecting incoming ballistic missiles. So at the moment it's pretty difficult to get in there. Hopefully we'll get in. Hello.
I can see you've got another 9 slides, so that won't be possible.
Okay, but can I just show you this
yeah,
one?
if you can just limit it to a couple of things, and then
yes,
please have a look in the chat. There's a lot of questions about where we can get map access, not the data access. So that would be something useful to just put in the chat.
I've got all that. I'll get to the end.
Yep.
So here is example in detail: Woodstock, Blenheim Palace. There's the vegetation object model. There, the next one is the aerial photo in comparison. You can see all the trees, including in the gardens. Zoom in, draw a profile across there, and you get the profile of the trees because it's kind of the full canopy height model. The draft X-ray evaluation is about 90%. It's a fully automated process, so we haven't done any manual QC and editing work, but it's there to be worked on. We think it's a really good product. Finally, here are the links to all this. And I will now put in the chat window the link which everybody can now preview the map, and because it's got a preview map in there, you can all zoom in on the map and look at your local area, 1 meter resolution, all the trees are there.
Yeah, thanks, and sorry for pushing you. And just everybody, just stay on that slide. The Esri Living Atlas is a place of lots of stuff. The challenge is once you're in there, it's like a very large sweet shop or warehouse. There is so much; it can be very overwhelming. And then back to the interoperability question, which I know the panel is itching to talk about. Often it's then difficult and hard to get things out into your own systems. Thanks, Alistair. We're going to round up the government agency with Jennifer from Historic England.
Hi, there's no PowerPoint presentation. So, Jennifer White, I'm the National Landscape Advisor at Historic England, and Historic England is a DCMS arm's length body rather than DEFRA. I'm a practitioner. I'm looking at how we could use these tools to help conserve and manage historic environment. And I'm looking at a spectrum of places, right from urban through to the rural. And at the moment, my head is spinning with all the wonderful things that have been shared this morning. There's just so much to sort of take in. So really useful workshop. I'm very grateful for that. So like everybody at this workshop, really interested in right tree, right place. And from my perspective, where is that in the historic environment? What are the opportunities for new tree planting, and where can we be using tree planting to help conserve historic features and historic landscapes? So in very brief, all the historic designations like listed buildings and registered parks and gardens are point and spatially mapped on the National Heritage List for England, and that is an open data source and available to sort of download. And that map continues to develop. So we're there's new listings, new registrations going on all the time. That data is also integrated with other government data sets. And we haven't mentioned so far, I don't think, MAGIC, which is the multi-agency GIS data set of all sorts of environmental information. And that goes beyond destination. So it has a lot more habitat information, but also information from the historic environment sector, like historic landscape characterization. And Martin has also included some historic environment information in the new GI mapping tool. We're doing lots of projects, so we're very interested in the sensitivity of landscapes and how we can actually identify opportunities for change. And we've been working with the Environment Agency on using historic landscape characterization to do that. And that's a bit of ongoing work, so it's very much at the development stage. We've also been working with organisations like the National Trust, looking at climate change mapping of risks. Trees are very important features in the historic environment. I mean, there's numerous. I'm not going to go through it all, but they're either important as individual features or because they're adding to sense of place. And of course, as people have mentioned in the chat, trees are of important of heritage and cultural importance too. But they sort of straddle between all the different sectors. So the conservation areas are perhaps one of the few historic environment designations that actually recognise the immunity of trees, and it's actually part of the conservation area planning and assessment. And the other thing that's coming forward now is the local lists, the local heritage lists that are maintained by local authorities to begin to expand to include trees too. I'm particularly interested in historic parks and gardens, and there the register of parks and gardens, especially historic in England, is really a record of the importance of these sites as designed landscapes. And so the trees and the treescapes are recognised as being part of the structure of that design, and there may be interesting features like specimens, but the register entries don't actually record the trees themselves. So in terms of conservation planning, tree surveys are an essential step, and most sites, estates will have some sort of survey. And it was Daniel who gave you a nice demonstration of that. Actually, we've got lots of historic data that we can draw on as well, particularly the first edition Ordnance Survey maps. But in terms of looking at the challenges ahead in terms of climate change, and particularly looking at the pest and disease threats to trees and treescapes, I have no way of actually aggregating all those surveys together. And we did do some sort of pilot work just to see what we could do. So there is huge potential in applying tree mapping in terms of sort of historic landscape conservation, and I'm all ears in terms of where we go from here and how this all could be progressed. And I'm very, very grateful to lots of people at this workshop who've helped me along the way in just trying to understand where the barriers are and what the opportunities might be. And I would echo that list of problems with tree data that Martin shared.
Superb. I'm just looking through the chat, and yeah, thanks, Jennifer. There is a lot, and we will strive to gather all the various strands. And I think, again, I'm repeating myself, even just a list of resources that exist is a very good starting point. I'd like to now invite the panel to switch on their cameras. So Mark and Sarah and Mark and Alistair and Keith, Tim, John and Matthew, whoever is there. So we've already had a little bit of chat in this chat, and there's another email group going around. And so the idea is now we spend the next sort of 45 minutes till 1 o'clock UK time, having some thoughts, sharing some thoughts that you might have, and then potentially see if we have some more questions from the floor that are a bit more sort of strategic and general. So I'm going to start with so my list. If you before you do make a sort of statement or response, if you just want to quickly introduce yourself, say a bit about who you are and what your thoughts and feelings are about today. I want to preface this, there don't have to be immediate solutions, because we can obviously see from the interactions and how many people are in the call that might not be possible today. So I'm going to start off with Mark Enzer, who's just happens to be the top of my list.
Holger, thank you very much. So I'm Mark Enzer. I'm a strategic advisor at McDonald, and up until quite recently, I was the head of the National Digital Twin Programme at the Centre for Digital Built Britain. So one of the things that means is that I'm not a tree specialist, but I am a data guy, and I know what good looks like. And I have to say that this is absolutely excellent, what I've seen today. So I mean, first of all, I want to congratulate the organisers on putting together such a high quality workshop. I couldn't believe it. Presentation after presentation was absolutely fascinating and interesting. So from my perspective, this is amazing. The point that I was quite keen to pick up on was that of interoperability, because it seemed to be relevant to quite a few of the presentations. And Holger, I completely agree with you on the fair data principles. I'm totally on board with that. And the I in fair is interoperability. And it's so important because if we don't have that interoperability of data and kind of effectively set up a data infrastructure, then forever we will build friction into the system of data sharing. And so one of the key things on the National Digital Twin Programme was about this. It's about secure, resilient information flow across organisational and sector boundaries. And it seems that is utterly relevant in this space too. So just super briefly, some of the things which help to unlock that interoperability we found is to have consistent high quality data models. The consistency is important in that. You can't have everybody with completely separate data models, because that means translation. And the other thing is around having shared reference data that would be managed by an authoritative source. And it seems to me that if you could move towards having just those two things, it would make a massive difference. But the main thing I want to say is that what I'm seeing in this space is hugely impressive. So thank you.
Very, very good. Authoritative source is of course something that seems very pertinent, as we've had a lot of authorities in the room today. Sarah from DLUC, would you like to just say hello, who you are, and any first initial thoughts?
Yeah, thanks, Holger. Yeah, I'm Sarah Allen, Head of Architecture in DLUC, and I advise the government on sort of design policies and implementation, particularly around housing and creating well-designed and beautiful places. And wow, what an amazing morning. It's really fantastic, and sort of really sort of rich seam of information. I'm neither a specialist in data or a specialist in trees, but I just think that there's some really immediate sort of takeaways for me, and the first one was several of you this morning emphasized the importance of collaboration, and I think particularly the opportunities of local authorities sort of sharing their learning and I suppose to build sort of skills and capacity around how data is managed, but also the content. So a few weeks ago, the government launched the Levelling Up and Regeneration Bill, and within that, well, it introduced it to Parliament, and within that is a sort of stipulation around design codes, and that local authorities will produce area-wide design codes. So we're doing quite a bit of work at the moment to look at what that means. But I think from today, what seems really important, it's not about sort of just what places look like and just looking at character, but actually the importance of being able to gather data to understand sort of performance of place, and that a lot of this work feels a really important starting point. Obviously, there's lots of data on all sorts of different layers, but I think sort of nature as a point of entry for people to really engage with their built environment and to understand the sort of complexity is something that is really invaluable. I think the other thing that stood out for me was that data mapping isn't static. And I think sometimes in the worlds that I'm in, sort of architecture and urban design, that you could do a sort of character study and it sort of stays as it is, and we sort of work in PDF format. There's a lot of work that's being done in the department around planning, looking at the role of digital tools to, again, sort of help with the planning application process, but also the sort of spatial planning side as well, and how local authorities can sort of have more control of this. And I can see real opportunities here of using the work and the tools that you've all shown to sort of help bring that to life, but also to connect with communities and allowing people to engage at really early stages. And that's one of the opportunities that design codes can bring. So I think that's probably all I'll say for the moment, to allow time for others to say their piece.
Yeah, thanks a lot. And we've just had a quick chat between the two of us. I quite like the idea that you mentioned, capacity building. What we've seen here is a lot of capacity, but it's probably not as equally spread. And there's a question in the chat there from Susan about natural England, historic England, and what they do for the other regions of the United Kingdom. The Geospatial Commission is very interested in working as Cabinet Office across the whole of the UK, but we do obviously all know that we have devolved responsibilities for many of the things we're talking about. So I don't know all of them, but we know that there are obviously equivalent authorities and agencies in all parts of the United Kingdom. I would like to go next to Mark from DEFRA for a few words.
Thank you very much indeed. Obviously, within the trees team, within DEFRA, where I'm leading on the statutory tree target and also on net zero, we obviously have great interest in the mapping of trees. Firstly, with respect to reporting of woodland area, which was reported this morning in our statistical release at 9:30, but looking forward to meeting the statutory target, which, as proposed, is an aggregate of woodland area and tree canopy cover outside woodland. So that's an important direct need for the mapping of where the trees are. Second area is looking at how we direct where trees are planted. Firstly, where the constraints to planting are, for example, where the land is too rocky, too salty, or too wet, and also the sensitivities, which mean that tree planting may not be appropriate, and to make sure that the tree planting is consistent with the UK forestry standard, with country guidance, and that the woodlands are, we'll use the phrase, the right tree in the right place for the right reason. The third area is identifying where we really want the trees rather than where they can be planted. And that is where the public goods are delivered. A really good example of that was the Environment Agency's Keeping Rivers Cool data set, which we're currently incorporating into the more payments. So that's the area where we need to. And the final area is looking forward, I think, to what remote sensing can provide. For example, if we can pick out where individual species are planted, which would be useful from a plant health perspective. For example, the current work on the location of Norway spruce in southeast England as a result of the ITS outbreak. And I think also the impacts of climate change, if we can pick out where the trees are stressed as a result of ongoing climate change. And the final area where wearing my other hat with the Forestry Commission is whether we can verify carbon stocks and carbon units associated with the Woodland Carbon Code. So I think from a DEFRA trees perspective, there is a very wide range of interest in tree mapping.
Thanks for that. I'm not sure whether it was my network or everybody else, or whether it was you, Mark. We just lost the final few words there. I hope I'm still visible and you can hear me. So Tessa, also from DEFRA, from the land use team. Sorry to keep you waiting. Over to you.
Hi, thank you. Yes, I'm Tessa Wardley. I'm in the land use policy area, and as Mark, very much has the detailed tree view of things in terms of DEFRA, but we cover in my team a much broader whole land use change area, and the work today is just absolutely amazing, because obviously everything we do is reliant on having good information, and trees are a fundamental part of what we're trying to achieve in terms of reaching net zero and Environment Act targets, as well as wider 25-year Environment Plan goals, reducing flood risks and recreation heritage access, and many, many goals that we aim to achieve in our land. And this covers also the rural as well as the urban context. There are sort of particular areas where the sort of mapping that we've seen this morning will be extremely useful. There was an announcement this week as part of the food strategy that we're looking to publish a land use framework next year, and the decision points and making those decisions and how we go about making those decisions is extremely reliant on good information and mapping to deliver that. So in sort of the urban area, that might be more related to sort of green infrastructure and green infrastructure mapping, and on the broader sense, the local nature recovery strategies that are kicking off and the opportunity mapping that goes into that. Those are the kind of public-facing mapping information and resources that are required for people to make decisions and to identify opportunities, but also in terms of the evidence that we're developing to back up the development of land use frameworks and our approach to land use. We work with a lot of modelers, spatial modelers. We're working with Geospatial Commission and NCA, but a lot of academic institutions as well, and they're all very, very reliant on these kinds of data and the mapping and modelling information. So it's fantastic to see you know, the work that's going on in there and the progress that's being made.
Great, thank you. And I now have Keith from Natural Resources Wales, quite fitting with the discussion about devolved. There's more in the chat about devolved responsibilities. So Keith, I can't see you right now if you are in the room. If not, we have Tim. Let's do Tim, also a devolved player from Cambridge Council.
Yeah, I'm the Planning Policy, GIS and Data Technical Officer for Greater Cambridge Shared Planning Service, which is South Cambs and Cambridge City. I mean, there's fantastic presentations that we've seen and some really good stuff out there. I think it just shows the huge volume of data that there is out there. And there's you know, there's lots that we'd like to do and could do with that. But you know, as with all data, you need to be clear about the quality of it, the source of it, you know, and that it's not just the initial getting hold of the data and creating the data in the first place, but also once you've done that, the maintenance of it, keeping it up to date, changes and so on and so forth. And that can take a huge amount of time and resource to actually do. There's some work that we've done with colleagues in the Cambridge City sort of tree team, looking at canopy coverage in the different wards and potential planting and that sort of stuff there. And just the sheer length of time that it took to undertake some of that work really can't be underestimated. And you know, for a lot of people, particularly on the data management side of it and the GIS side of it, this would just be a small part of the bigger job that they have to do. So I think there really needs to be a bit of an understanding of that and trying to sort of pull things together. And you know, realistic, you know, really there has to be a focus on what can realistically be delivered and getting the organisations that are all working to be clear about what they want from it and what can be achieved with the resource that we have there.
Yeah, thanks, Tim.
Probably about it.
No, that's great. And I didn't want to rush you there. We do actually still have good 28 minutes. Not speaking here on on government policy or on behalf of the Geospatial Commission. Just personally, I've just had a few personal notes in the chat. Would it not be, in terms of Mark mentioning authoritative data, would it not be sensible for some of the government agencies and actors here to come together at the table and provide a couple of the data sets that sort of seem to fulfill 80% of the requirements of everyone, not at the specific level, like with the presentation itself from Germany. You know, there are always more specific requirements at the local level, but there might be some national, and I mean this actually as UK-wide, and we've also had comments about the Republic of Ireland, and we also have international people in the room, but certainly for England, Wales, Northern Ireland and Scotland, there might be something we can do. And of course, we had the start of the day with Blue Sky Mapping and an Ordnance Survey, who is responsible for GB. There are some data sets that are widely available, but as we all heard all day in the chat, if you've been monitoring the chat, my head is spinning as well. Knowing where it is, knowing that it exists is what we're getting to, but then where is it? Like the EA LiDAR data, which is one of the most fantastic data sets. And you could just see during Alistair's presentation, people saying, where is it? Where is it? Well, here it is, there's a catalog, but most of the audience, I felt, just wanted to see the pretty maps you had on your slides, and they couldn't just quite get there. So, yeah, thanks for your thoughts, Tim. I've just got on my list, I think, of the people who we had on the panel. We've got John and Matthew. Are you both also from Cambridge, Greater Cambridgeshire Authority? Is that right? Yeah.
Holger, they agreed that just Tim would represent Greater Cambridgeshire, but is Sam Grant here? Because I think she was going to pick up at least the DEFRA biodiversity. Cool. Oh, Sam, sorry, I just saw Sam, sorry.
Yeah, sorry, Sam. I didn't have your last name, and I didn't have you on my yes, apologies. Sam from DEFRA as well.
That's all right. Thank you. So I'm Sam Grant. I work in as a statistician for plant health and tree health and bee health in DEFRA. So I'll just obviously not go over what Mark mentioned about the right tree in the right place, but I guess for us, a key issue of data that we have huge gaps in is around species levels, which species of which trees are where, which is essential for kind of our surveillance work, for risk work on pest and disease. And it's absolutely, some of the stuff that we're seeing this morning, my head, like a lot of people's, is spinning. There is so much going on in this space, and lots of it looks fantastic. I think from a technical point of view, there are questions, and I think other people have touched on them, about how you bring some of that data together, transparency around how it's collected. You know, is the tree standard being used to collect that data? Is it timely? Is it easy to extract from one system and bring into another? So I think those would be my points about how do we take all this individual work and, for my purpose, build it up into quite a comprehensive wide-scale map that allows us to look at pest and disease and its potential to spread in the future.
Yep, cool. A combination, yeah, it's very recurring themes, and Mark has just put in the chat to wanting to talk about connected digital twins. And I think, yeah, the level below that would just be a set of connected national maps. It seems to me. So I'm getting loads of personal messages here. Thanks for all that. Keep it going. With a few of you, I've shared my email at the Geospatial Commission. Again, you know, we're not here to solve all problems immediately, but if you have specific use cases, please get in touch. And also you have, I'm sure, the other colleagues from DLUC and DEFRA would probably, hopefully, all be happy to talk to you in the chat as well. Cool. So I think, again, if my panel colleagues can help me, if I have given everybody the first sort of chance to speak, then I think we just have about 20 odd minutes to perhaps raise our hands in the room or post another few overarching questions, or if anybody on the current panel feels that they would like to add. Yeah, Mark, might as well go.
Yeah, thanks, Holger. So this was about the connected digital twins, because it does feel like it's relevant. And we heard Sven talking earlier about digital twins and the Singapore example. So I'm not sure if the language of digital twins is familiar in this space, but it just seems that the concept of digital twins and connected digital twins is really relevant. So maybe if I just took a couple of brief moments to introduce that and do so in the context of systems and systems thinking. Because Holger, you opened up the whole event talking about the vision for the built environment and kind of recognizing that the whole point of all this was to drive better outcomes for people and society and nature. And the way to get to those better outcomes is from the systems and the services that the systems provide, rather than just individual interventions. But that then kind of asks the question, how do we understand the systems better and intervene more effectively? And I think that's where digital twins and connected digital twins can be really helpful. But the point of connecting them really is to be able to make more sense of systems and connections. So just to take a little bit of a step back on that systems view for a moment, I think when we do look at the big challenges that we face just now, like climate change, achieving net zero, achieving climate resilience, achieving circular economy, you know, these are clearly systemic challenges and they can't be solved in silos. So we need to have systems-based solutions. And I guess if we look in cities, it feels like a system, doesn't it? And it's a kind of a system of built systems and natural systems, and the interface between them becomes incredibly important and valuable. And so, you know, a lot of what I've taken from this workshop is the role of trees in relation to health outcomes, air quality outcomes, temperature control, all sorts of things, which are super relevant in a city. But there are other things that affect that as well, you know, energy, transport, water. And so I guess what I'm just trying to paint very briefly is this picture of interconnections. And if we buy into that and we think that the way to get to better outcomes is by understanding the systems better and intervening more effectively, then we need tools to do that. And that's where digital twins come in. And I think that a lot of what you have presented today are kind of the beginnings of digital twins in this space. We can imagine them being connected up, but particularly when it comes to doing kind of clever things with them, kind of working out some what if scenarios, like what if that tree grows? You know, what impact is it? It's not just looking at what the tree is just now, but what it will be. And all these kind of things can come from interacting with digital twins. So I guess the thing I just wanted to do, Holger, is just kind of drop into this community the idea and the language of digital twins and connected digital twins.
Yeah, totally, and thanks for that. And I'm going to just build on that. I think it was a beautiful example of now from Norfolk, how we have historic maps going back 120 years showing us where trees were located in 1880. And what Mark is looking, so we have a lot of historic records which we're increasingly digitizing. And what Mark is referring to here is that in the future, and the note from Tim about how up-to-date these data sets are, which is a challenge. The idea, of course, with a digital twin is in its purest and most advanced form, it would be a digital replication of the physical, both the natural and the built system, which does at some point in a building sense, or in an engineering sense, it might even have sensors that inform the digital equivalent immediately of a change. Now, we have talked today about sensors from space, LiDAR satellites. So you can see where we might be going, that we actually have maps and models of our natural environment, which are equally as up to date as the real world is. Seems all very much far into the future, and it is. But yeah, have a look at again, as I said in my opening, today is very much about making the connection between the systems and between the various disciplines. Have a look outside your own box and look into what Mark and the team at Cambridge have been doing in the sort of built environment, and see where there are parallels. Anyone else from the panel, or Sue, or the host? Yes, Sue, you've got your hand up. There we are, perfect.
I'm unmuted. So two things that have come over to me. One, looking at the chat, a lot of us just feel technically illiterate. You know, we don't understand a whole lot of its stuff, and yet we're in sort of decision-making roles, but we don't understand how to handle things. Every time Mark explains digital twins to me, I think, God, that's so sensible. But I can't go any further than that. And quite a number of people have said, is there any way we can raise our skill level in actually at least knowing what's being talked about? So that was on the one hand. On the other hand, who's going to take ownership of this? You know we need this national data. We know we need to get everything integrated. Who's going to take ownership of it so that we can all access it? Because at the moment, it's in several hands. Some of it's open source, some of it's privately, commercially driven, and so on and so forth. Who's going to take ownership so that we can actually all work from the same base information. Deadly silence.
No, and it's good to ask the questions, but I think you will not be, certainly from myself, getting an answer that it should be X, Y, or Z. But the question is definitely is in the room. So I
feel it needs to be in the room. I'm not expecting you as Geospatial Commission to answer that, but I think it's a question that's sitting in the room like the sort of proverbial elephant that we never get round.
Yes, and there are, of course, several actors in the room and well, we still have 182 participants, so I'm actually very grateful for everybody holding out and making it to the end. There are several national, GB and UK players in the room who should be thinking about that question. Cool. Some people are saying goodbye. That's fine. We do still have some time. Just going to go back to the chat and see if there is anything.
Kieran's got his hand up.
Oh, sorry. Yeah. Go.
Yeah, I didn't want to take away from the current conversation, but I think actually, as there is an actual pause, I'll add this in. You know, one of the objectives of today's workshop was to build collaboration. Now, maybe because of commercial sensitivities and business needs, that's not always so possible. But one of the things I really liked that's come forward today is the idea of standards. Standards, you know, in laboratory world, in chemistry world, you often have certified reference materials that people have to compare against and validate their processes against. And maybe actually one thing that we can think about and bring forward here is some standard data sets of trees that other technologies can compare themselves against or measure themselves against or provide a variance against. And I put in the chat the idea of the iTree Eco data because it is probably the most comprehensive field tested data set from across the country, 30 plus studies now across England, Scotland, Wales, and indeed now Northern Ireland, a study there, tens of thousands of trees measured. So probably nearly hundreds of thousands of records. Now, I suppose I just wanted to pop it out there as an idea, because if we had some of these trees that were measured by professionals to a high level of confidence, then others could compare against that. Obviously, land use can be a bit of an issue, accessibility, but there are plenty that are openly accessible. I just wanted to voice that while there was otherwise a pause. And maybe that's one mechanism is what I'm suggesting to allow verification of these various technologies that we've heard about today.
Superb, thanks for that. And just looking at the another chat here that we said at the beginning, we have a graphic illustration of this workshop in progress. I can't wait. If it's anything to do with my current state of my mind, it will be more like a bush or a hedge, a very chaotic hedgerow rather than a beautiful tree. So we've had some comments. Well done, Daisy, for that very comment at the end there. You would have heard me and others say this before. There is actually not another 10-15 years to plan and have all sorts of committee meetings about this. You're quite right. There are some issues that we need to solve now. What stuck in my mind earlier was I can't remember, apologies, which presentation it was, but some council planning to do planting, I don't know, 50,000 trees or whatever it was, the number, and then working out later that we don't actually have the space for it. So there are some, feels to me there are some tools in the toolbox that we heard today that should be immediately available. Yeah, well done for that comment. Emma, the other quick question, I was going to just type, but whilst I'm here, I can maybe you can just quickly come to the floor. Is the chat captured, all the text, and before we switch off and yeah, okay, cool.
I think it should, Holger. And I asked a question out to people there just now. We've heard a lot of different things that are on tree maps today. Is there anything that's missing? And so somebody mentioned condition and tree health, and I just wondered if anybody had any thoughts on what we are not yet capturing by this huge and impressive range of tree maps.
Also, Sarah made a really interesting point that it's less about an organisation owning the information, but the potential of collating the different sources into a portal. We don't know who would do that, but are the various contributors kind of interested in, if some sort of portal could be organised, would they be interested in actually helping to populate that? So there was one place where you knew where to go for what and why, is the sort of, I suppose it's the question. And some have been, so I'm going to a quick pitch to DEFRA here. We do have, for example, there is a, is it magic? Is that the right term I'm using here? There are some portals, but again, there are several. And Sue, your point about skills, really well made. Not all of them are as accessible as they could be. So great. And so just having a look, tree standards. Yeah, we're so back to Kieran's point. Yeah, keep posting in the chat, and then the call here up there about, you know, don't worry about pitching a group on LinkedIn or anything. This is what this is all about. You know, don't feel that you should be able to post anything you feel is useful for the group. And last, are all the people who've presented happy if we have PDFs of their presentations to put on the website so that people will be able to see the recording, but sometimes you want to pause on some of the graphics in the presentations. So can we assume that's fine for everybody? Take that as a yes, I think. Yeah, super. And when you just mentioned the website, that is the Tree Action and Design Group website. Yeah, it's the TDAG website under events. Well, it'll be under past events on that by the time we get it up there. Superb. So on my program, it says that I will be saying a few words to close the meeting. Absolutely, I think we have achieved one of the main aims, that is flushing out everything that exists to do with trees from the micro scale, from the 3D scans, from the UK scale. We've had presentations from Germany, and we've had certainly in the audience people from across the globe. So we've sort of got that. We have also achieved one of my personal aims, that this shouldn't be like too much about pitching this is the best solution and my map's better than yours. I think we've achieved, certainly the chat has been all very very collaborative as opposed to competitive. And I think with Mark's systems of systems thinking, I think increasingly we are aware that working together is needed to tackle the challenges that Mark so eloquently quickly summarized. So the steps ahead, we know a few steps are clear. We will be sharing and Sue will be sharing presentations. The community, certainly we have now a list of interested parties, whether there might be another event. There are regular events, you said in the chat earlier, of your group anyway. So staying in touch, the government agencies and arm's length bodies and central departments have all heard loads of pertinent questions and suggestions. They can all take those away to their own meeting rooms and think about those. Thanks for the direct messages to me, and I enjoyed the interaction. So final thanks. I said this earlier, I now say it to still 162 remaining people that Emma, Sue and Kieran has been one of the most best organized and facilitated by yourselves meetings in a long time, having an agenda 2 weeks before and having a first initial meeting about the meeting 6 weeks before, which has been really good. So I think we've been credited by that, that we still have over 160 people in the room, hopefully all listening. And thanks for all the thanks in the chat. We will capture all those as well. So Sue, Emma or Kieran, a final word? If not,
that's it from me.
Of course,
Yes, Sue.
a final word from me as ever. It was to thank you very much, Holger, for chairing it. I thought you did superbly, because then kept virtually everything to time, and we can all now go and have lunch. So thank you very much for doing that, Kieran and Emma, and I really appreciate it. And I'm sure everybody else does too.
We really do. Thank you.
Yeah, and enjoy the sunshine and have a good afternoon or day wherever you are. Bye-bye.